Hello, hello. Am I audible to everyone out there? I'm audible to everyone out there. Come on, just quickly give me a information. You're waiting for everyone to join in. Let me just check if I'm audible. You're waiting for everyone to join in. Let me just check if I'm audible. Okay, the audio is crisp and clear. Let's reduce the gain a bit. Okay, we have 40 watching now. So what will we be today doing today? We'll be solving all the LeetCode monthly challenge problems. So basically, there is a LeetCode monthly challenge that goes on where you're given monthly challenge problems, and that is what we will be solving today. Will I be explaining? Yeah, definitely. I'll be explaining all the questions. The questions which are easier ones, I'll be coding and explaining the questions which are related to dynamic programming, trees. I will try to use iPad to explain, but apart from that, most of the questions which are easier short, I'll just go and code them without actually wasting a lot of time. What is the number of problems that I'm expecting to do today? It's around 16 to 20 is what I'm planning. 4 per hour is what I'm expecting to do. Let's see how much can I have time till 12, 1, 2, whatever, till I get good watching. I'll definitely solve. The moment I have a drop in watching, I'll stop. That is what the plan is. Okay. So to start with, let's quickly wrap up with the introduction part for everyone new out here. My name is Raj Vikramaditya. I'm known as Striver in the programming community. Currently, I'm a competitive programmer. I'm working as a software engineer where that people will tell you on the chat section. I'm a candidate master at Codeforces, a 6-star rated coder at CodeChef. I've been teaching from the last couple of years, and I also run a YouTube channel which has around 130,000 plus subscribers. Goes by the name Take You Forward and Striver. You can definitely check it out. The subjects that I primarily take are competitive programming, DS Algo, and C++. A lot of times, candidates do miss out on great opportunities due to multiple reasons. They do not have a great degree or a poor network. Your resume must not be standing out among all those thousands who are applying for a particular startup, or you are being applying to 50-60 companies but you're not hearing back. That is where something like Relevel comes in, which is India's first test hiring platform backed up by Unacademy, which is helping job seekers find their dream jobs. And you can get a job on the basis of your skills and talent. You need not you don't need to have a great degree or a great CGPA or a great LinkedIn connection. So that is when Relevel comes in. What is Relevel? Relevel is basically a platform where there are over 50 plus companies, including India's top startups and unicorns like Misho or Fred, Urban Company, Razorpay, 1MG, Yellow Messenger, Codenation, and there are a bunch of other companies over Relevel. Now, how many job openings are there? There are approximately 1,000 plus job openings, including business development, front end development, and back end development. You can attempt this test for free. Yes, the test is absolutely free. There is no charge for this. You can attempt this test. Once you finish the test and clear the cutoff score, which is 700, you get to apply to your dream company, and all of these stuffs will be finalized within 15 days, interviews and everything, and you can get your offer letter within 15 days. Select the test of your choice. You can have business development test, front end development test, and back end development test, and book a slot whenever you wish to give the Relevel test. You can use my promo code, which goes by the name SCRIVER Striver, in order to get a free sample test paper, which you can use right before the mock test. And all the best if you're willing for if you're appearing for Relevel. So what are you waiting for? The link is in the description. Go and check it out and appear for Relevel as soon as possible, because there are a bunch of companies which are waiting for you. Okay, cool. That was more about the stuff. Now we'll come across to LeetCode. Let me just adjust my screen according to that. I was speaking a bit fast. आदत है, क्या करूँ? हाँ, हेयर कट रोज होता है क्या? नहीं. I just took a shower. That's I just took a shower, nothing else. And yeah, let me just quickly log this. Looks perfect. So basically, for everyone out there, I have solved 1, 2, 3, 4, 5, 6, 7 already. And if you want to check that, you can just go to youtube.com. You can just type CodeBeyond. Okay, the moment you type CodeBeyond, you will find a playlist. Okay, so there is something as Raj Striver's playlist. So over here, if you go to the live problem solving section, there will be there will be something like, yeah, daily challenge. This is where I had already solved the first 7 problems. Yes, so 1 to 7 has been already been solved over here, which is lead code daily challenge by Striver. So you can definitely check it out for the first 7 problems. So we'll be starting across from the 8th problem. Make sense, everyone? Make sense, everyone? Is that clear to everyone? Is that clear to everyone? कि पहला 7 सवाल का solution कहाँ मिलेगा? I've solved all the 7 problems, so you can find that out over there. Okay. So we have done those. Now we'll be going across and solving this binary tree tilt. Okay. So binary tree tilt is the question. I'll give you a couple of minutes to read the question and then I'll get started. That's an easy one. So I solved this. No, I haven't yet solved it. So given the root of the binary tree, written the sum of every tree nodes tilt of the okay, let's read the question. Given okay, by the way, let's have a target of at least 2000 likes. At least. यार आज मैं लंबा stream करने वाला हूँ. I need motivation. Please give me some motivation by giving me wonderful likes और कुछ नहीं. Please read the question. Till then, I will get started right in a moment. Cool. I mean, if you've understood the question, can you give me a UQ? Also, have you understood the question? Can you give me a UQ? Can you give me an EQ? I understood the question. Can you give me a super quick UQ? फोन को साइलेंट करते हैं यार. So basically, what is the question stating? The question is stating you're given the root of the binary tree, okay, and written the sum of every tree nodes tilt. So what is tilt? Tilt is the absolute difference between the sum of all left subtree node and all right subtree node. If a node does not have a left child, then the sum of the left subtree is treated as 0. And if it does not have a right, then it's treated as 0. So it's an easy one, right? So if you stand at 2, then there is no left and no right. So 0 and 0. So there will be 0 for 2. For 3, again, no left and no right. So 0 and 0. For 1, the left child has 2 and the right child has 3. So 2 minus 3 will be 1. So basically 0 plus 1 is equal to 1. That is what you need to give. And that's what the answer is. So what I can basically do is, if I am having the root, correct, what do I require? I require the tilt. So probably I can carry some variable. Okay, so let's carry some variable. What's the size? 1000. So yeah, it will suffice. Integer will suffice. And now what I can do is probably I can call this helper function or the traversal function, whatever you call it, your wish, and you can pass on the sum. Now what you can do is you can have a private function, definitely, and you can be like, let's do a traversal because it's a tree problem, correct? It's a tree problem. So if I'm looking for left and right subtree, we know there are a couple of traversals that do it. Three traversals. One is the in order traversal, the other one is the pre-order, post-order. Now which one will we use over here? we need to have traversed the left as well as the right, and after that we need to compute. So it's the post order that we will do, correct? It's a post order that we will be doing. So what I can do is int function, and we have a tree node star of root, and we can keep the summation as something like this. And I can be like, if it at any moment it comes out as null, I can return it 0, because it was clearly stated that if it does not have a right and left, it will be 0. So I'll return 0, correct? And I can say there is something as left sum. So can I say the left sum will be the function which basically is root left, and I can just pass on the same sum. And can I say the right sum will be a function, and similarly root of right I can pass on the sum, correct? And now can I say if I have a left sum and right sum, this function is something which returns the tilt. What is tilt? It's the absolute difference between the sum of all left subtrees and the right subtree node values. That is what it is. So can I say that summation will be taking absolute of left sum minus right sum? That's for sure. And what is the subtree's sum? The subtree's sum is nothing but left sum plus right sum plus the roots value itself, because that is what the subtree sum is. So this function returns the subtree sum, and every time I go to left and right subtree, I get the subtree sum. So tilt will be nothing but this. And right at the end of the day, I can definitely return the sum. Does that make sense to everyone? Does that make sense to everyone? US, if I've understood this. Can I get a US if I've understood this? Can I get a yes if I've understood this? Again, do not go on the runtime and faster. You can see the runtime is 23 milliseconds and it's giving faster than 53.01 seconds. If I do submit it again, you will see the runtime changing. Okay, so do not bother these things. If I submit it again, you'll see just a minute. You'll see again it is changing. So do not get bothered. Now, if I analyze the time complexity and space complexity, it's very simple. If in order to understand this, you should be knowing trees. So in trees, there is a property of subtree sum. So what you basically do is left sum plus right sum plus roots value. This is what the subtree sum is. So I have written a function which returns you the subtree sum. Okay, so this function is what is return. This function is returning you the subtree sum. Okay, that's an easy one. So basically what I'm doing is I'm getting the left subtree sum and right subtree sum, and it was clearly stated that the tilt is nothing but the absolute difference between the sum of left subtree and the right subtree difference. So what I did was, whatever left subtree sum I got, whatever right subtree sum I got, I just subtracted them and I took the absolute difference and I added that to sum. That is what I'm doing. Got it? And why am I not returning sum? Because we want the function to return the subtree sum, not the tilt. Because if I return the subtree sum, that will be used in above. Got this? Like for 2, if I return 0, then there's a problem. I want to return 2. So that for this one, the left subtree is 2, right? That is what I'm doing. Got this? Got this, everyone? Is this clear to everyone? Now I have to go quick. See, I'm assuming you know these topics. In that sense, I'm solving. I'm not solving as if you don't know trees. I'm assuming you know trees, you know DP, you know graphs. That's how I'll be solving those problems. Got this? So if you don't know trees, go and watch my trees playlist. I'm assuming you know programming, you know trees, and on that assumption, I'll be solving it. That's it. Why not returning sum? Again, I have told you this. I had read your graph series, but I don't like the way you change the code at GitHub. So if you're so cared about zero-based indexing and one-based indexing, I think in my videos I did teach zero-based indexing. And in GFG, it was one-based indexing. So I had to change the code. So it's absolutely okay, man. If you can't understand zero-based and one-based indexing, there is a problem. Correct? So Stuart, that's your problem. Concept समझ लो यार, उसके बाद one-based indexing, zero-based, you can code it yourself. Okay, cool. Clear है सबको? Why we did not return the sum? Because sum is the absolute difference. And we want always the subtree sum. And subtree sum is nothing but the left sum plus right sum plus root value. Clear है? सबट्री सम रिटर्न करने से फ्यूचर में हम टिल्ट निकाल सकते हैं एंड सारे टिल्ट का समेशन ले सकते हैं. इट इज नॉट अरे सबट्री सम विल कंटेन. सी गाइस, आई एम for people who are asking why not sum, I'm sure that you don't know trees, so please go and watch our trees lecture. It's a very simple question. If you know how to find subtree sum, this is very basic. Okay. Why root val? Otherwise, how will subtree sum get computed? What is subtree sum? Himself and the left and the right. That's it. Simple. Okay. Shall I move ahead? Shall I move ahead? Shall I move ahead? US, you see from everyone. Okay, moving ahead. So the question is done, and the complexity is big O of n because you are traversing in an post order fashion. Okay, so complexity is big O of n, and you're using a space that is a stack space, which is again big O of n if it's a skew tree. Okay, and you can remove the space. How can you remove it? No, you can't remove it. You can't remove the space because even if you do a linear traversal, you have to know the left and right, so you have to use stack. Yeah, that's the best we can do. Cool. Moving ahead to the next question, which is jump game 3. It's a good question. It's a DP question. So I will read the question and then I'll explain you using my iPad. I'll explain you using my iPad. This is an easy question. Please go through the question. That is what I'll explain. That is what I expect you to do. Guys, let's take it to 2000 likes. Just 130 to 170 watching. And guys, come on, let's take it. अगर 4 घंटे बाद 2000 लाइक्स स्ट्रीम पे होने ही चाहिए मिनिमम. It's an easy one. It's a very easy one. Please go through this. UQ, if I've understood the question. UQ, if I've understood the question. I don't care. कोड शेफ पे कॉन्टेस्ट होगा कोई बात नहीं क्या फर्क पड़ता है I have more of interview related audience. It's okay. UQ. Let's understand the question. So given an array of non-negative integers array, so basically what they're saying is they'll give you an array of non-negative integers. All of these are non-negative integers. You are initially positioned at start index of the array, so they will be giving you a start index where you will be standing. Now when you are at index I, you can jump either to I plus, like you can move to the right by I plus array of I, or you can move to I minus array of I. Now check if you can reach to any index with value 0. That is what you have to check. Like, can you move to any index with a value 0? Notice that you cannot jump outside the array at any time. So for an example, if the starting position is 5, which in this case is 0, 1, 2, 3, 4, this case 3. So what they're doing is, no, sorry, this is index 5. 1, 2, 3, 4. Yeah, this is index 5. So this is the start position. They are saying let's move back by 1 place. So they moved back to 3. Then they're saying let's move back to 3 places. So they moved by 3. Then they're saying let's move front by 2 places. So they reached a position which was 0. So if you can reach a position that is 0, you have to return a true. That's what they want you to say. If you are given a starting position, you have to tell me, can you reach any other positions or not? Is that clear to everyone? Is that clear to everyone? Question is clear to everyone? Questions clear to everyone? Is the question clear to everyone? Okay, questions clear to everyone. So what's the basic approach that outside गया तो वाला path नहीं लेंगे. What's the basic approach that you can think of? I know there is a starting index, right? I know there is a starting index. So if I apply a BFS approach from the starting index, where can I go if I ask you the simple question? And the answer to that is Striver. From the starting index, we can go either right or we can either go left. Correct. So if I think in my brain, if I go to right to some index, from there, again I can go right or left. From those, I can again go right and left. So can I say there are multiple possible paths that I can follow? Do you agree? There are multiple possible paths that I can follow. Like if I start from start I can go to right, to left, and from there again to right, left, again from there to right, left, again from there to right, left, again from there to right, left. So can I follow multiple paths? And while following multiple paths, if I reach any index which is 0, I get my answer. Correct? Now tell me one thing. If I'm following couple of paths and I reach an index, मैंने स्टार्टिंग में एक बार आया मैं एक इंडेक्स में पहुंचा एंड उसका एक लेफ्ट था, उसका एक राइट था. तो मुझे जब मैं दोनों तरीके, लाइक व्हेन आई वेंट लेफ्ट एंड व्हेन आई वेंट राइट, आई डिड नॉट फाइंड एन आंसर. एंड अगेन इफ आई समडे after a lot of days, I again come back to that index. And again I say, let's go left and right. Should you go again? Like once, if you have checked for a particular index, will you check for it again? That's the catch over here. Will you check for it again? एक बार उस इंडेक्स से चेक कर चुके हो कि जा नहीं पा रहे हो कहीं भी, तो you'll not check. So that's the catch. So what you will do is you'll try to explore all possible paths. So when I say you're going to try to explore all possible paths, what does that give me? That gives me that, okay, probably I can use recursion, but I'm not a big fan of recursion if this can be solved using BFS. So I can say, okay, we can definitely explore BFS. Now what I will say is, let's explore BFS where I say, okay, Striver, let's take a queue. Okay, and I'm like, when am I starting? I definitely know that I am starting at a position which is the starting position. Everyone knows that. Do you agree? This is where I am starting. Now, can I say, if I am starting at this position, in future, if I come to the start, should I again start from this? It will not make sense. Once I've started, if I again come back via any loop to that same starting position, we will not go again. So thereby what I said was, okay, let's do one thing. Like ideally you can use a visited array. I'll recommend you to use a visited array. But in this problem, you can use this, like you can change this array as well. So what I said was int start, I'll just keep it -1. Stating -1 states you won't be going anywhere. Why? Because it has clearly stated all are non-negative integers. So -1 states this has been visited. Okay? Got it? This has been visited. Now, can I say queue not empty? I can. Now, at which index I am? Q dot front, Q dot pop. Now, can I say one thing? I will only start a journey from here if this guy, like, in case I reach, what can be the cases? I can go left, I can go right. So let's try to go left. Now when can I go left? What is left? I know left is nothing but index minus array of index. That's for sure. And I know what is right. Right is index plus array of index. Correct? Does everyone know this? Now can I say I can only go left if that's inside my boundary? What's the other stuff? If that's inside my boundary, I can go left. And if that guy is not visited previously, so since I'm marking it as -1, if it is greater than, like I can say it's not equal to -1, that has not been visited previously, thereby I can definitely go. So if I can go, let's keep the left. Okay, and similarly, can I write for right? For right, can I write if that's lesser than n, where n can be the size, okay, so what I can say is right lesser than n and array of index is not equal to -1. In that case, I can definitely go to right, correct? And over here, if at any moment I reach an array of index which is equivalent to 0, I can say it's a true, or else over here, I can say I have explored all the paths, I did not reach my answer. Got it? So if I run this, will it run? By the way, right hoga. If I run this for this particular test case, I think it should run. Yeah, it is running. And if I submit this, it will be true. Oh, runtime क्या आ गया? कहाँ चेक नहीं किया भाई मैंने? ओवरफ्लो बहुत ज्यादा बड़े नंबर से क्या? 5 into 10 to the power 4. चुप माही चुप है राजा. एक सेकंड ये ओवरफ्लो क्यों आ रहा है? Oh, my bad. We have forgotten that these guys will no more be executed. So please mark them as unvisited. My bad. Please mark them as they have unvisited. अब चल जाएगा. Runtime error. टेल ही खा गया होगा. Buffer क्या हो रही है? Heap buffer flow on address. Same code is running over here. Why it is giving? Same code. Just a minute. Array of left, array of right. Marking तो कर रहा हूँ. रुको एक सेकंड. If I'm not going q dot front, that's the index. Q is q dot start. Vector int start. Q dot front, q dot pop. If array of index is 0, will return a true. Can go left, yes. Index minus. If that's greater, then please go. And if it is not equal to -1, it's not marked, please go. Mark it as -1. Q dot push. Q dot push right अगर lesser than n है. N क्या है? N is array dot size. That's correct. Man, क्यों कहाँ रहा है? Heap buffer flow. What the hell is this? एक सेकंड. Oh, I understood. Aha. That's how bad. We are marking it as 0. Just let's check if at any moment we are getting a 0 so that we can directly return. Yeah. We can directly return a true over here. And similarly, we can directly return a true over here. Cool. Equal to 0. That's correct. Return true. In case we are reaching. This should be fine. Yeah, should be fine. टाइम एरर क्यों आ रहा है? सेम यहाँ पे चल रहा है सेम चीज. Just give me a moment. Code. Why this is creating a problem? नहीं इजी वीजी कुछ डीएफएस इजी ऐसा थोड़ी होता है. नहीं डीएफएस इजी ऐसे थोड़ी कुछ होता है. एक सेकंड रुको. कुछ तो हम लोग छोटा सा मिस कर रहे हैं जिसके चलते नहीं हो रहा है. एक सेकंड दो. ट्राई रन कर लेते ना फटाफट से. अगर ये 0th पोजीशन है तो 4 है. तो अपन के साथ क्या हो रहा है? 4 हो रहा है. तो इंडेक्स +4 हो रहा होगा. array of index plus 4, 0, 1, 2, 3, 4. 4 गया. No, why do you need DP? Why do you need DP? That's my question. No, why do you need DP? That's my question. Just give me a moment. Just give me a moment. Let me check this across super quick. Left is greater than equal to 0, and array of left is not equal to 1, which is correct. So array of left is mark that as and push the index. It's correct. Right is index plus array of index. That is again correct. Q dot front, Q dot prop, Q dot not empty. Again correct. Q dot push. सही है. Start वाला position 4 2 3 0 2 1 3. Why will be initial index negative? Just रुको एक सेकंड. ओहो, यहाँ पे दिक्कत आ रही है. We understood कहाँ दिक्कत आ रही है. Actually, we are marking it as -1. Let's, for a betterment, let's take integer visited n, because we did mark it as that's the main problem. Okay, let's just do this over here. So okay, cool. Let's mark this off, and now it'll be fine. Let's just change this to visited, and let's mark visited of start is equal to true, is not equal to, is equal to false. Let's keep visited equal to true. Let's keep visited equal to true. Let's keep visited equal to false. Should be fine now. True. Perfect. Cool. So basically the mistake that I did was we assigned array to -1 at the starting. So whenever there is an index minus, it was giving you wrong indexes. I kept on running. That is the reason, because we did change array of index. Thereby there was the main issue. Got this, everyone? Clear है सबको? The other thing that we could have done is we could have just negated it. मतलब यहाँ पे negate कर देते तो भी हो जाता. यहाँ पे अगर negate कर देते तो भी हो जाता. ठीक है? यहाँ पे अगर negate करते तो भी हो जाता. But as everyone got this using a visited array in order to solve this. So basically what I did was I tried across going to the left and to the right, and after this, that's your choice. If you want to change the initial array, you can, or else you can use the visited array. That's fine as well. Like generally it is being suggested that don't change whatever is given as input. Try to have your own set of variables in order to solve a problem. ठीक है? Clear है? Recursion में भी same complexity आएगी. So has everyone understood this? Just maintain a visited array and your job will be done. Just maintain a visited array and your job will be done. Recursion is easy, man. Recursion left right चले जाओ. अगर कोई भी जगह पे easy आ रहा है तो मतलब mark कर दो. Stack भी use कर सकते हो. You can use stack as well, because it doesn't requires you to find the minimum number of operations. If the question was for minimum number of operation, then Q was essential. Why don't we solve it using recursion? I don't prefer recursion. That's why. Like you can solve this using recursion as well. If you wish to solve this using recursion, you can also solve it. That's quite simple. If you're willing to solve this using recursion, again, just keep a boolean visited array of size n. Like you can keep a vector something like this, or you can keep 0. Like if you're willing to solve it using return check, starting position is definitely start with the array and the visited array. That's it. So you can just write the return function privately do. Like you wanna write the recursion people are asking. So and index vector int array vector int visited. So what you can basically do is, if you are any moment coming across to an array of index which is a 0, you can return a false. Sorry, you can return a true. And if at any moment the index is out of bound of array of size, or index is lesser than 0, so in that case also you can return a false, because that's not possible. And over here what you can do is, if visited of index is equal to true, if it's already been encountered, so you can definitely return a false. And you can just go to the left check will be check index plus array of index with the array and visited. And whenever you come to visited of index, just mark it as 1. And the right check will be check array of index minus array of visited. And at the end of the day, you can return a left check or right check, whichever is the answer. That's it. That's how you can definitely solve this as well. Okay, अब यहाँ पे क्या दिक्कत है यार? So you can solve this as well like this. Simple enough. Recursion भी कर सकते हो, BFS भी कर सकते हो. तुम्हारी मर्जी है. Like, you can either do recursion or BFS. That's it. Why did I avoid recursion? Because recursion does use a visited array, as well as there's a stack space that you end up using. So there are a couple of space complexities involved. There's a couple of space complexity. No, why and? If any of the portion gives you the answer, that's true, right? If any of the portion gives you the answer, that's true. Time complexity is big of n, but the space complexity is big of n for the visited array and the big of n for the internal stack space that it is using. Got this? That's why I did avoid recursion, because like Q में भी use हो ही रहा था, तो ठीक है, चलता है. Q में भी use हो रहा था. But yeah, both of the methods. Both of the methods clear. Go back and watch the BFS code. What is this? Please show the BFS code. There is a dragger है यार, screen पे dragger है, drag करके देख लो. Yeah, you can see that there's a lot of places to do stuffs. As I said, there's a lot of ways in which you can do this. You can use this visited, you can modify this array, but in interviews it is recommended whatever input is given to you, please do not. Yes, that is what I've said. In BFS also it would have taken queue space, but I'm not a big fan of stack space because कभी कभी overflow हो जाता है. That's why. Anyways, cool. Let's move to the next question. US from everyone, please. US from everyone, please. US from everyone, please. US from everyone, if you have understood this, so that I can move to the next one. Can I do the US from everyone so that I can move to the next one? Go fast. शॉर्टेस्ट पाथ पे यहाँ पे 1+ ऐड कर देना, अगर शॉर्टेस्ट बोलेगा तो यहाँ पे 1+ ऐड कर देना, and basically, and after that you have to return the if it was the shortest path question minimum, and यहाँ पे DP हो जाता बस. The shortest path would have been both recursions का minimal. That's it. Simple as that. So shortest path would have been that if it was the shortest path question. What's the status of videos editor recruitment? The recruitment has been done. Okay, Domino, and this is a good question on DP again. Initially the bot DP questions, yeah. It's a good question on DP, so I'll recommend you to do this. Yeah, you can see as a what did I say? If you can do it without modifying, try doing that. But if it's absolutely necessary that you have to sort the array, otherwise you cannot, then it's fine. Okay, I want you to read the question and give me UQ the moment you understood the question. Give me UQ the moment you understand the question. डिजिटीपी का एक मस्त सवाल है, उसको लास्ट में करेंगे, नहीं तो फिर लोग भाग जाएंगे, जितना भी लोग देख रहे हैं वही भाग जाएंगे. I'll do the DigiDB question in the last. It might take me 30-35 minutes, but I'll do it in the last. It's a good question. Alright, it's kind of a shit question, but it's a good one. Enjoy, it's a good one. So, please read the question. That is what I'll recommend you. Ready to read the question, please? Please read the question. चुप माही चुप है राजा कृपया करके क्वेश्चन पढ़ के हमें बताया जाए कि आपको समझ में आया है. Did not understand the question? Anyways, please try to understand the question. चुप माही चुप है राजा. Thank you. Been getting a lot of compliments about my haircut. Is it that good? Okay, let's read the question. So basically, you're given a couple of tiles of 2x1 domino shape and a tromino shape. So basically, domino shape is this shape, which is kind of a vertical, a horizontal. क्या बोलते हैं? Horizontal, vertical. VS है horizontal. Horizontal 2 steps, and tromino is this. Now, what they are expecting you is they'll give you an n. Okay, so basically, if n is given as 3, which means you have 6 length to fill up. That is 1, 2, 3, 4, 5, 6. You have 6 length to fill up. So I can say I can put 2 wala like this, a 2 wala like this, a 2 wala like this. And I can say a 2 wala like this, a 2 wala like this, a 2 wala like this. Or I can say a 2 like this, and a 2 like this. Or I can say I'll put a tromino, I'll put a tromino. Or I can say I'll put a tromino, I'll put a tromino. So these are the ways that we can do. Imagine if it was a 4 wala stuff, I would have also put a tromino, a dual, and another tromino. So this would have been a size of 4, like if there was a 4 length. So this is also possible. So this is the question. You have to figure out in how many ways can you form the n length, the n cross 2 tiles wala step by using a domino and a tromino. Is the question clear now? Is the question clear? Let's have 300 likes at least for the starting. 2000 likes bahut dur lag raha hai. Is the question clear for the starting? How many ways can you place dominos and trominos such that you're able to make a 2 cross n tiles? Got it? Amazing, amazing. That's good, that's good. Kind of, yeah, you can solve this using recursion. Yeah, that's correct. You can solve this using recursion. You can definitely solve this using recursion. सोच तो चलो. Okay, everyone has understood this? Okay, everyone has understood this. Perfect, perfect, perfect. So, not understanding question. Question पढ़ो यार. Question पढ़ो नहीं तो समझो कैसे. Question तो खुद करना होगा ना. अभी देखो मैं तुमको ये समझाता हूँ DP से. तो पहले तो recursion समझ जाते हैं कि how can we place and all of these shits, and then probably we can think of the other stuffs. ठीक है? Okay, let me just use my QuickTime Player. use cool. Let me see if it is visible. नहीं visible नहीं है. Perfect, perfectly visible now. Let me just go across and understand this again. So abhi, if I try to draw it, what do we have? We definitely have a domino and we definitely have a tromino. Correct, something like this. And if I think about this, can I say we have like always approach a recursive problem in order of indexes. So we are given indexes that we have to fill. Okay, we have given 3 indexes that you have to fill in this case. So always try to approach the problems in terms of indexes. Try to write recursions. Start calling. Try to write recursions in terms of indexes. Okay. Now, if I ask you a very simple question, I know the tiling is like this. Like for n equal to 3, the tiling has to be like this, where you have to fill up 3 places. Do you agree? The tiling has to be of like something like this. You have to fill up like this. Correct? Now, if I ask you a very simple question and I ask you, how can you fill up the first index? You'll be like, Strive, I have a couple of ways to fill up the first position. And you'll be like, I can fill a domino and I can move ahead. Like if I ask you on basis of indexes, on this index, what can you do? You can be like, Striver, for type 1 is what I can fill a domino and I can move to the next index. Do you agree with me? On this first type, I'll fill a domino and it's a one way. There's one way to fill a domino. Do you agree there's only one way to fill a domino? Everyone? Does everyone agree that there is only a one way to fill domino? Right? Perfect. So what's the other way that you can fill the domino? अरे एक ही तो वे से domino fill कर सकते हो. ये वाला example. ये वाला example. ऐसे तो fill होगा ना domino. In this index, this is the only way that you can fill a domino. Got it? That's why I fill. Nikhil, got it? Okay. So we have figured out that we can fill the domino in one possible way. Now, can I say, but Striver, I am interested in filling the domino in this portion. I'll be like, okay, that's the type 2. You'll be like, okay, I'll fill the domino like this. But can I definitely say, if I fill a domino like this, it will end up taking couple of places. Do you agree with this? That if I fill the domino like this, it will take a couple of places, right? Couple of indexes. Thereby, can I say, if I fill on this index, index plus 1 automatically gets occupied. Thereby, I will have to move to index plus 2 if I fill the domino. So if I fill it horizontally, vertically, jo bhi bolte hain, if I fill it in this portion, the dominoes will be filled like this. 2 indexes, index and index plus 1, and I have to move to index plus 2. So that's one of the other ways that I can fill. I'll decide to fill it like this, or I can decide to fill only a single column, or I'll decide I'll fill 2 columns like this. Okay, so that's another type that I can fill. Do I have any other types? I don't think I can, because vertically I've tried, horizontally I've tried. Let's try for other stuffs. So if I think of domino, I don't think there are any other ways. I can either fill it like this or I can either fill it like this. Correct? So for domino, I don't have any other ways of filling. Now let's think for tromino. Let's think for trominos. So if I ask you for trominos, what can be the option? You will be like, Striver, if I try to fill the tromino, it will take me 2 index and index plus 1, but this portion will stay empty. Like a smaller portion will stay empty. So I'll say you, okay, I'm absolutely fine with that. You can go ahead, because even if this portion is empty, going ahead, you can definitely place a domino and then a tromino. Or you can be like placing a tromino. You still have an option. So this is a possible way. So I will tell, hey, listen, if it's a tromino, what you can do is you can go ahead to index plus 2, saying them that there is an empty space. there is a space. Tell them there is a space. Tell them there is a space. We'll think about this afterwards. We are saying them that there is a space available in the previous tromino. What can be the type 4? If I ask you what can be the type 4, can I say the type 4 can be, I'll place the tromino in this way, where I leave a space over here. Again, for this also, I will move to f of index plus 2, stating there is a space. So f of index plus 2 is twice. So I can say twice of f of index plus 2 if I'm willing to place a tromino. Can I say twice of f of index plus 2 and a space if I'm willing to place a tromino? Do you agree with this? Do you agree with this? Do you agree with this or not? Please tell me. यार बताओ यार, अग्री करते हो कि नहीं? ये ट्रोमिनो का 2 प्लेसमेंट्स विद स्पेस बचेगा, अभी भी स्पेस बचा हुआ है मेरे पास. अग्री करते हो? So now what I've done is I've introduced a variable space into it. Yes, if I carefully observe, I've introduced a variable space into it. So it might happen because if I'm moving to index plus 2, it says there is a space in the previous index. So we will come to cases where we will reach an index with space. So assume I reach an index and it says there is space at the back. So if there is a space at the back, how can you place a domino is my question to you. If there is a space at the back, how can you place a domino at the back? If there is a space over here or over here for that reason, can I say you have 2 options. Either you say I will place a tromino like this or probably a tromino like this and I will fill it up. I'll fill it up. So if I place a tromino on this index, I will, like, if I'm coming to this index with a space, if पहले से मेरे को कोई बोल रहा है कि एक space था, can I say I'm coming to this index and I can place a tromino now? I can place a tromino now. And if I place a tromino, then I can say I will move to index plus 1, which is the next index, and I will have no more space. I will have no more space if I place a tromino. Do you agree? Tromino in a space, if I add a tromino in a space. Agreed? If I add a tromino in a space, there will be no spaces required. Agreed everyone? क्योंकि ट्रोमिनो जैसे ही करेंगे, एक इंडेक्स पे था, ये वाला भर जाएगा या फिर ये वाला भर जाएगा, जहां भी स्पेस हो. अग्री करके. अभी टाइप 6 क्या हो सकता है? टाइप 6 हो सकता है मैं ट्रोमिनो, if there is a space, even if there is a space and I'm at an index, I will say let that space be there. I will go on with the space. I'll place a domino. So if I place a domino, this guy is on a space. So I will move to f of index plus 1 with a space. Even if I say I'll place, like, if the tromino was like this and I place a domino here, this guy is with space, where assuming this is the index, thereby f of index plus 1 with a space. So if I am placing a domino, remember this, if I am placing a domino, then the previous space still remains. But if I'm placing a tromino, then the previous space is no more. In this way, can I go and filling up and trying all possibilities. Have you understood? Now, when I write the recursive code, you'll understand. But have you understood? Have you understood? Have you understood this? All cases. Have you understood all the cases? Please tell me if you have. Please tell me if you have. इंडेक्स प्लस 2 क्यों होगा? तुम अगर एक डोमिनो प्लेस करते हो, पिछला वाला खाली था, तो पहला पोर्शन पिछले वाले में जाएगा, एंड डोमिनो का एक पोर्शन इधर आएगा, तो तुम इंडेक्स नेक्स्ट में तो मूव करोगे एंड यहाँ पे स्पेस रह जाएगा. या फिर यहाँ ऐसे मूव किए तो यहाँ स्पेस रहा और यहाँ ट्रोमिनो था, तो यहाँ प्लेस किए तो एक प्लेस रहा और तुम इंडेक्स प्लस 1 में तो जाओगे. विल ऑलवेज गो टू इंडेक्स प्लस 1, राइट? क्लियर है? Is that clear to everyone? I'm asking everyone. So there are a couple of cases. Whenever you reach an index, there might be space. There might not be space. Let's understand. There are a couple of cases. There might be place. There might not be a place. Understand this. ठीक है? अगर मैं को n equal to 3 दिया हुआ है, there might be a couple of places where I say there is a space or there might not be a space. Agreed, everyone? Does everyone agree with this or not? So if there is a space, if there is not a space, if there is not a space, ठीक है, if there is not a space, then I'll be like ठीक है, space नहीं है तो मैं डोमिनो प्लेस करूंगा. अगर मैं डोमिनो प्लेस करता हूं, मुझे पता है मैं डोमिनो किस तरीके से प्लेस कर सकता हूं. ऐसे प्लेस कर दिया, ऐसे आगे जाऊंगा तो स्पेस होगा नहीं, या फिर ऐसे प्लेस किया तो भाई 2 आगे जाना पड़ेगा बिना स्पेस के, या फिर ट्रोमिनो ऐसे या ऐसे, which is f of index plus 2, बट ट्रोमिनो प्लेस करूंगा तो स्पेस रहेगा. 3 states, करेक्ट. आई एम सेइंग इंडेक्स पे पिछले वाले पे स्पेस था, स्पेस था, तो 2 ऑप्शंस, इधर ट्रोमिनो डाल, और ट्रोमिनो डाला तो नो स्पेस, और डोमिनो डाल, और डोमिनो डाला तो स्पेस. बन गया मेरे सारे स्टेट्स. By the way, this will be twice because the tromino can be placed like this or like this. So that's why twice. A tromino can be placed in couple of ways. How was that? How was that for an explanation? Did you understand it? How was that for an explanation? Did you understand it? And this is when I haven't taught you the basics of DP. I just explained you the recursive natures. How can you place a tromino? Yeah. That's why we moved Aditya index plus 2. That's why we moved index plus 2. Has everyone understood all the cases? How am I covering it? Every stuff. Has everyone understood this? Has everyone understood this? Can I get in here? Can I get a response on the chat box? Can I get a response on the chat box? Less people. So this is how the DP series will be. इससे भी like यहाँ तो मैंने सही से समझाया भी नहीं. DP में तो आराम से समझाऊंगा अपना टाइम लेके, because वो built up होगा. But yeah, this is how it will be. Cool. So we know this. So what we will do is we'll try to write the recursive solution. ठीक है. Add a function. You'll always see try to convert DP problems into index problems. ठीक है. And write boolean space. So initially space you can just keep it. Now remember, there can be couple of cases where you say you're filling and you crossed out of the boundary. So probably what I'll do is just to reduce variables, I'll keep a private and just keep an n over here, and I'll just pass it up. So if at any moment it crosses, then it's a 0. Okay. But if you're able to fill up, remember this. If you're crossing it, then there's a problem. But if you're able to fill up all the indexes, assume that we are starting from n. DP सीरीज आएगा. DP के प्लेलिस्ट आएगा जल्दी आ रहा है. DP के प्लेलिस्ट अभी प्रेशर कुकर में मतलब सभी बन रहा है. The DP playlist is on the verge of being ready. So yeah, that's what. So can I say if I'm reaching the index equal to n, that means मैं लास्ट इंडेक्स में पहुंच गया हूं. तब मुझे पता है अगर मैं लास्ट इंडेक्स में पहुंच गया हूं तो एक ही तरीका है. अगर स्पेस नहीं है, if the space is true, like अगर स्पेस नहीं है तो ही 1 रिटर्न होगा, क्योंकि अगर स्पेस नहीं है तो एक डोमिनो ऐसे लास्ट इंडेक्स में बैठा देंगे, बन जाएगा. तो रिटर्न 1. लेट्स काउंट. रिटर्न 1. बट इफ देयर इज नो स्पेस देन यू कैन नॉट. इफ देयर इज स्पेस तो तुम एक जगह में कैसे भी डोमिनो ट्रोमिनो बैठाओगे. अगर स्पेस नहीं है तो क्या हो सकता है, सोच के बताओ. कैन वी प्लेस इट? वी कैन, आई गेस. कैन वी that's a question. Can we? Yes, we can. So if you're reaching index equal to n, प्रोसेस को रुको, कॉम्प्लिकेट हो रहा है, इसको इजी करते हैं. चलो इसको इजी करते हैं. अगर अपन इंडेक्स ग्रेटर देन like we are filling it up, so what's the last index that we will not fill? If you're reaching n plus 1, that's the last index where like after filling n, we will reach here. So we can return, like if I'm reaching here, then it's perfect. And I can say कोई space नहीं है अब. कोई space नहीं है. तो return 1 कर दो. Else return 0 कर दो, ये easy रहेगा. If you have filled up all the places. ठीक है. And if at any moment you cross n plus 1, then it's a return 0. No way. Let's assume you crossed it, so no way. So that's what you can do it. Now let's try it out. So if the space is true, that's one of the cases. And the other case can be else the space is not true. So count all. So the first recursion, if the space is true, I'll count that as if the space is true. I can definitely place a tromino and I will move with no space. So false, no space. Or I can definitely place a domino and I can just move it with a space. Perfect. And if the space is not there, I can be like, okay, there is no space, so I'm starting off. I can move to the next index with no space. Domino place kar diya. I can place a domino horizontally and I can move here without a space. Or I can place trominos like ऐसे, which is twice into f of index plus 1, and this time there will be a space. And I have added all of them and I can return the count. So over here what I can do is I can return function of initially start placing with index 1, and what you can do is you can just initially see the space to be 0, and that's what the answer will be. Perfect. आया समझ में? सारा मेरे केसेस लिख दिए हैं, सारे केसेस को लिख दिया अपन. Is this clear to everyone? So the recursion code should be working. Let's check. कुछ तो issue होगा. Go Shankar. Why did not work? No, just a minute. क्या हो गया इसको? चला क्यों नहीं? इतना अच्छा डीपी मैंने लिखा है, चला क्यों नहीं? कैसे नहीं चलेगा ये? इसका बाप भी चलेगा. How did this not work? Count plus return 0. That's correct. This is correct. This is also correct. No, we are considering 4 directions is not possible now. How will, if you place it like this, how will you cover this portion? So this direction is not possible. We ended up counting a lot of places. That's 3, 9 and 5. The answer is coming out to be 9. Then did we overlap some cases? Or what? If space is this, count is 0. नहीं मॉड्यूलो तो ठीक है यार, मॉड्यूलो तो बहुत बड़ा नंबर है, तो इसके लिए तो बहुत छोटा ही है आंसर. 3 के लिए तो 5 ही आ जाना चाहिए ना, इसके लिए 9 क्यों आ गया? एक सेकंड रुको. Let me check out. Just give me a moment. Let me check out. Oh, it's correct यार. Space is false. तुम्हारे पास स्पेस नहीं है, तुम इस इंडेक्स में पहुंचे हो तो सारा फिल कर चुके हो, तो इसको गिन, अदरवाइज मत गिन. सही तो है. काउंट प्लस इक्वल टू काउंट प्लस स्पेस अगर नहीं है तो फिर इधर आएगा, नहीं तो इधर आएगा. If equal to 1 index space. For a single place, 2 tromino happens. No, that's correct. This is correct. Each correct. Oh ho. +2. My bad. +2. At tromino गिराएंगे तो second index पे जाएंगे ना. My bad. If we have a tromino, we'll go to the second index. I think this is what we have written as state. We have written the states. My bad. Sorry. Now it is fine. So first thing, modulo. So there is something that they are saying कि modulo करो इतने नंबर से, तो फटाफट इसको modulo कर लेते हैं. पहला बात तो let's do a modulo. So again, constant and mod equal to 1e9 plus 7. So first thing foremost, you have to do a modulo. So just do a modulo, whatever answer is there. I'll now try to have a dp. So we can have a dp like this, a vector of int and dp. So just pass on the dp over here, 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 pass on the dp over here. And at the end of the day, you can just keep a vector of int dp. What will be the size? The maximum size can go up to n plus 1. Yeah, n plus 1 जा सकता है. With vector of int n plus 1, ये 2 जाएगा, space with -1. So that is what I've given. I've given them the dp, and just in case, this is where we will write the dp. If dp of index and space is not equal to -1, can you please return the dp of index and space? And over here you can just try dp of index and space. That's how you convert a recursive solution to a dp solution. That's it. So yeah, should be fine. Yeah, should be fine. So this is how you basically do. Yaar. Shit. Cool. So is this clear to everyone? This is how we can definitely solve it. Yeah, done. This is how we can definitely solve it. So is this clear to everyone? How I transcripted a recursive solution, how I thought. So all the problems in recursion, try to solve them using indexes. Try to think what can you do on a particular index. Java code, use an array list of array list na. What Java, man? Concept is this. This is the concept. That's it. Write this in any language. Can I get a US? Can I get an US for this at least? Can I get an US for this at least? I'm not going into space optimizations. This can be definitely space optimized, but I'll not go into them. That's basically you can do this using a 1D DP. Like a 1D DP में हो जाएगा with n into 2 cross size. I'll teach this question in my DP series. ठीक है? I'll teach this question in my DP series where I'll also optimize the space complexity. Okay, so we can definitely optimize the space complexity, but for that I'll teach you a trick in my DP series जिसमें कोई भी दुनिया में प्रॉब्लम हो ना, अगर इंडेक्स प्लस 1 और इंडेक्स प्लस 2 ऐसा कुछ हो रहा है, स्पेस ऑप्टिमाइज होता है 1D DP. This is basically a 2D DP where you're using n plus 1 into 2. But I'll teach you to do it as space optimization. And that I'll teach you. ठीक है? मजा आया सबको? मजा आया तो? This is how the DP series is going to be. It's going to be massive. बस मैं घर से आ जाऊँ. I'm going tomorrow home. So let me come back from my native place because I have my गृह प्रवेश. तो मैं उसको करके आता हूँ. भैया डिनर तो कर लो, डिनर साथ साथ करो, ले लो पानी पियो. Next one. It's an easy question actually. I'm not sure why is this tagged as hard. I did not find this question hard. For me at least, for me. So this is the next question. Please elaborate on it. Yeah, space optimization as knapsack, kind of. Basically, this question can be written in iterative. Once you write iterative, you see index plus 1 and index plus 2 is what matters. So you just carry on two variables and you can just remove all the space complexity. So that I'll teach you afterwards. But as of now, today I'm just focusing on logic. I hope you've understood the logic. नया घर, हाँ मैंने एक नया घर बनाया. So I'll show that to you guys very soon. Not the flat that I took. It's one more home that I've made. I'll show that to you. I'll take some time for DP series. Yaar. I do work full time. You need to understand this. I have a full time job. Don't expect so much from me, yaar. Don't expect so much from me. Yes, Isham. This can be optimized. Hey, Isham, यार मैं तेरे को personally पढ़ा चुका हूँ ये चीज़. Isham, I've taught you personally this stuff. ये कैसे होता है बताया था ना क्लासेस में. Okay, next one. Please read the question. Please read this question, then I'll move across. Guys, 500 likes been here. Oh shit, man. We don't even have 500 likes. That's it. This is very bad. कल मैं कोड प्रोफाइल रिव्यू कर रहा था वही I got around 400 views. Sorry, 700 watching था एक टाइम पे. Anyways, read the question. Let me know if you've understood this question. कोड चेक चल रहा है भैया, बस ये बोलने आया. प्राइवेट मत करना. नहीं करेंगे प्राइवेट, डोंट वरी. No, I'm not taking any further classes. Sorry. जितना मैं फ्री है फ्री में पढ़ाता हूँ. अभी तो कोई ऑनलाइन लेने का मूड नहीं है. No online classes. Sorry. I have stopped taking online batches. Sorry. It's a huge commitment and बाद में लूँगा. शायद February से शुरू करूँगा. Not sure. Let me just get a bit settled down. Have a bit of time. Probably after that we can start online classes. But as of now, no paid classes. Okay. Is this question clear? Can I get a UQ? ये बियर्ड पे कलर क्या नहीं, बियर्ड पे तो कलर नहीं है. इट्स नेचुरल. भैया मैरिज पे सबको इनविटेशन चाहिए. हाँ भाई शादी कर लेता हूँ. लड़की है नहीं, शादी कर लो, हद्दी है. A positive integer is magical if it is divisible by either a and b. So basically you have to return the nth magical number. So for an example, for 2 and 3, if I try to write down, it's 2 3 4 6 8 9. So this is how the list will go, because every number is either divisible by 2 and 3. Every number is either divisible by 2 and 3. So output is 6. Why? Because they wanted you the fourth number. The fourth number is 6. UQ question is clear. So what is the first solution that comes to your brain? The first solution that comes to my brain, at least, is the brute force, which is very simple. It's very simple. What you basically do is you go on int I equal to 1, I lesser than, ignore this, and it'll be like, okay, int count equal to 0. So if I modulo a equal to 0 and I modulo b, sorry, or I modulo b equal to 0, just do a count plus, and if at any moment count is equal to n, you can return the I. That's the brute force. But the complexity is going to be huge. And it will give you a prob. 2019 में solve किया था. कैसे solve किया था 2019 पे? Binary search. Binary search. Okay, so that's how you can do this. Okay, that's how you can do this, and this is definitely not the solution. So this is where we can think of something as what do you observe? First thing that I observe is we're running from 1 to a certain number. We're running from 1 to a certain number. Agreed? So can I say we know the range where the answer can lie? Like if I talk about the worst range, can I say the answer will be either from 1 to, assuming A is the smaller number, assuming A is the smaller number. Can I say the answer will be A into N? Like assuming there is no number that divides B. Like at the worst case, can I say if A is the smallest number, the answer will be in this range, 1 to A into N. Does everyone agree with me on this? The answer will be in the range 1 is to A into N, assuming B does not have any number that divides. Right? That can be the case. Like beyond A into N, you will never get a number, assuming A is the smaller one. So can I say, if I can do a binary search on this range, like I'll try to explain you. So can I say, if the range is, I know the range to be 1 is to A into N, assuming A is lesser than B. Okay. So if I know this is the range, can I do a binary search on this? I'll be like, yeah, Strive, I think we can do a binary search. So how can we do a binary search is a very big question. So I'll be like, okay, assume I get a middle. Assume the middle to be X. Okay, I'm getting in middle and that's X. So can I say this? I can actually find out how many numbers are lesser than equal to X that are divisible by A, that are divisible by B, and that are divisible in total. How can we find that? It's very simple. If I do X by A, will I get the number of numbers that are divisible by A? The answer to that is yes. If I do X by B, will I get the number of numbers that are divisible by B? Yes. Can I say A lesser than B? अरे मतलब assuming A B से छोटा है, तो assume कुछ ऐसा मैंने दे दिया तुमको 2 and 2000. तो अगर मैं फोर्थ नंबर खोजने बोलूं तो एट मैक्स आंसर क्या होगा? 2 into 4 18 होगा, वही लिखा है. अगर मैं फोर्थ नंबर खोजने बोलूं, n equal to 4 दे दूं, फोर्थ नंबर खोजने बोलूं जहां A ये है एंड B ये है, तो एट मैक्स आंसर क्या होगा? 2 into 4 at the worst case. That is what I've written. ठीक है. So can I say the total number of numbers that are divisible by A will be X by A, and the total number of numbers that are divisible by B will be X by B? Agreed. Correct. But there will be some common numbers which will be divisible by both of them. There will be some common numbers that will be divisible by both of them, which is nothing but X by LCM of A and B. So can I get the number of numbers? Will this give me the total number of numbers? Will this give me the total number of numbers that are lesser than equal to X and divisible by A and B? And can I say that if the total number of numbers is lesser than n, I know my answer will lie on the right half, because I have to increase the number, because the total number came out to be lesser than n. If it is greater than n, I know my answer will lie on the left half. Thereby I have to reduce the search space. I have to reduce the number. So are you getting a binary search pattern? Are you getting a binary search pattern? Are you getting a binary search pattern? I'll take an example and explain. Did you get the binary search pattern? Yes or no? आया? So अभी अगर एक छोटा सा एग्जांपल ले लेते हैं तो समझ में आ जाएगा पूरा. तो A equal to 2 and B equal to 3 ले लेते हैं. A equal to 2 and B equal to 3 ले लेते हैं. Let's take n equal to 4. ठीक है. N equal to 4. Now what I am saying you is I'm looking for n equal to 4. So I'll be like, let's do one thing. थोड़ा सा n को बड़ा कर देते हैं, थोड़ा सा स्पाइस कर लेते हैं. n को 10 कर देते हैं. ठीक है, n को 10 कर देते हैं. So can I say the answer will be from 1 to 20? कहीं ना कहीं इन्हीं के बीच होगा, 1 to 20. Okay. What's the middle? The middle is 10. How many numbers are lesser than equal to 10 and are divisible by both A and B? That's 10 by 2 plus 10 by 3 plus 10 by the LCM of 2 and 3, which is 6. Thereby 5 plus 3, sorry, minus 1, which means 7 numbers are there. There are 7 numbers lesser than equal to 10. But how many Sorry, my bad. Let me explain again. So I've taken a A, I've taken a B. I am saying 1 and 20 के बीच ही जो 10th number lie करेगा. Correct? Can I say this is mid? Yes. So can I say the total number of numbers lesser than equal to 10 and divisible by A and B will be 10 by 2, 10 by 3 minus 10 by 6, thereby making it 5 plus 3 minus 1. Thereby making it 5 plus 3 minus 1, which is 7 numbers. But how many numbers did you require? You required 10 numbers. So, इसके बीच कोई भी number लेंगे कभी नहीं आएगा. So my search space will be now 11 to 20. So in this way, can you just trim your search spaces? Now is it clear? Yes, I'm not going deep. Otherwise, सारे problems कर नहीं पाऊंगा. I'm not going deep. I'm just giving you the intuitions. And now I'll move on to coding it. I'm not going deep, guys. Yes. Meet Kataria. Go and watch my binary search masterclass. Go and write CodeBeyond binary search. If you want to learn binary search, lecture 1, lecture 2, lecture 3. No need to see anything else. Just watch these three classes. Binary search खून में बैठ जाएगा. Okay. Eat healthy. अरे इसमें healthy क्या है? अगर मैं इसको खा लिया इसमें क्या हो जाएगा भाई? So can I say low will be 1 and assuming if is greater than B, or just swap A and B, making sure A is always smaller. Assuming what's the maximum value of I? 9. What's the formula for LCM? Formula क्या था LCM का? Anyone remembers? याद थोड़ी होगा तुम लोग. Cool. So the numbers count will be cool. So that is how you can definitely do it, and I think this should, yeah, cool. Let's submit this. So that's how you can definitely solve this answer. Long way wrong answer. 423 पे कितना आएगा? 7 क्यों आ गया? कॉपी पेस्ट क्यों करना है भाई? इतना अच्छा तो इन्होंने जीसीडी बना के दिया है, व्हाई डू यू वांट कॉपी पेस्ट? एनीवेज लेट मी जस्ट क्विकली चेक इट आउट। क्यों नहीं चला? ये क्यों नहीं चला भाई? तू क्यों नहीं चला? The finding when to use binary search and how to use रिवाइज। पीछे आके देख लो ना। रिवाइज मुझे क्यों बोल रहे हो? रिवाइज करने पीछे मॉड से डिवाइड करना है, समझा नहीं? एक सेकेंड। नहीं नहीं वो ठीक है, वो तो बात का बात है। ये तो छोटा भी नहीं चला ना। नहीं इस कुछ तो इशू हुआ होगा, देख लेता हूँ। I'm taking answer equal to high. Okay, count is greater than 1. अरे अरे मॉड से डिवाइड करने से ये छोटा सा आंसर का क्या फर्क पड़ता है? I told a 7 and it's exceeding it 7. ठीक है ठीक है ठीक है ठीक है। Count is greater. Okay, count is greater. Just do a high equal to mid minus 1. That's correct. This is also correct. Mid minus LCM is correct. If it is coming out to be greater than n, अगर बड़ा है तो भाई तू, अगर बहुत ज़्यादा बड़ा है तो पंगे हैं। ये नहीं है तो ये है। ये काम करते हैं जस्ट फॉर चेकिंग आउट। अगर छोटा है ही तो फिर n को बड़ा कर दे, एल्स पे लगा के देखते हैं। Let's check this out. Should be fine. वो चल जाना चाहिए था, चला क्यों नहीं पता नहीं, देख लेता हूँ। एक सेकंड, चल क्यों नहीं रहा है? Is it giving me a division problem? Most assumably it's giving me a division problem. डिवीजन का इश्यूज तो दे रहा है। मॉड्यूलों का सीन नहीं है। अरे छोटे नंबर्स पे नहीं चल रहा ना, मॉड्यूलों का सीन नहीं, छोटे नंबर्स पे नहीं चल रहा। जस्ट एक सेकंड दो, एक सेकंड दो। डिवीजन का सीन होगा क्योंकि जब मिड जा रहा है लॉन्ग और डिवाइड बाई बी कर रहा है तो फट जा रहा होगा वो। ये कंफ्यूज सकता है और ये कंफ्यूज सकता है। क्यों हो सकता है? ये चल चेक करें, चल चेक दो। Okay. ये है ये मेरे पैसों तो बढ़ाएंगे। फिर काउंट सादा जा रहा है, फिर सादा है, फिर सादा है तो छोटा कर, फिर मॉड मार दिया। ये लॉन्ग लॉन्ग का तो फट रहा है, लॉन्ग लॉन्ग में ही फट रहा है मोस्टली। सी नहीं गारंटी तो है क्योंकि मैं इधर इधर कर रहा हूँ ना। गारंटी तो है क्योंकि मैं इधर उधर कर रहा हूँ। अब चल जाएगा। हाँ 4000 कैन नॉट बी रिप्रेजेंटेड इन इंटीजर, इंटीजर में रिप्रेजेंट नहीं हो सकता। लाइन नंबर 6 shits. Guys, ये कितना है? ये 10⁻³ है, क्यों नहीं चल रही है? लो प्लस आई, दैट्स ओके। लो एंड लॉन्ग लॉन्ग है ना, लो प्लस आई कैसे ओवरफ्लो करेगा? ओके, at the worst case even if I get 10⁻9 as low and a as 10⁻4, it's 10⁻9 into 10⁻4 is 10⁻13. So long should suffice, like long should suffice. I'm not sure why it is not sufficing, but yeah, it should suffice. Just for safety reasons. एक काम करते हैं, रुको, इसको मैं लॉन्ग इंट ले लूँ तो चल जाना। एक बार देखते हैं, इससे भी बड़ा वाला लेके देख लेते हैं, just to be safe, nothing. No. It's going somewhere fishy कहीं तो हो रहा है। चल छोड़ो, हो गया। सीपी होता तो सारा लॉन्ग इंट ही लेता। Yeah, we can return high as well. You can return high as well. That is correct. You can return high as well. That's correct. Just for better understanding, the हाई तो नहीं होगा, आंसर श्रिंक होगा, लो पे होगा आंसर ना, हाई श्रिंक हो जाएगा, लो पे खड़ा होगा, लो होगा ना आंसर, हाई थोड़ी होगा। ठीक है, so has everyone understood this? Has everyone understood this? I just converted everything to long just to avoid any, कहीं भी मल्टीप्लाई होके फट रहा होगा तो सारा कन्वर्ट हो गया, फटेगा नहीं अभी। is this has everyone understood this? कुछ नहीं चेंज किया यार, ये बेसिकली मैंने और एक फंक्शन लिख दिया जहाँ सबको लॉन्ग इंट बना दिया। एंड क्योंकि यहाँ ए इंटू बी करा था तो इंटीजर कहीं फट रहा होगा, कहीं ना कहीं फट जा रहा होगा, तो मैंने क्या किया, सारे को लॉन्ग कर दिया, तो लॉन्ग इंटू लॉन्ग ही रहेगा, फटेगा नहीं, कहीं तो कहीं हो ही रहा होगा, फट रहा होगा, पता नहीं कहाँ फटा। मोस्टली एन इंटू ए यहाँ की है ना, तो ये एन इंटू ए यहाँ फट गया होगा, यहाँ एन इंटू ए फट गया होगा, क्योंकि एन इंटीजर था, ए भी इंटीजर था, तो इंटीजर इंटू इंटीजर फट गया होगा। 1L is when you multiply longs. That's it. ठीक है, US from everyone I move. US from everyone I move. Nice. We have streamed 2 hours. No, not 2 hours. 1 hour 33 minutes only. मैं थका feeling आ रहा है यार. We just have 404 likes. Let's take it to 500. Come on guys, let's take it to 500. Time complexity will be logarithmic of this portion. Logarithmic of n into a. Yes, अंश, that was correct. ऐसे करते तो हो जाता, बट कितना जगह करता है यार, इसलिए मैं दिमाग नहीं लगा, मैं सारे को कन्वर्ट मार दिया। US from everyone? I don't say US from everyone. Come on guys, everyone give me US. I want everyone to give me a US before I move across. And I want everyone to give me a yes before I move across. हिमांशु कर सकते हो? Okay, I'll get something to eat. Next question. Moving across to the next question, guys, now. कौन सा था नेक्स्ट क्वेश्चन? nth हो गया ना, ये हो गया पार्टीशन. इट्स अगेन a DP. I want you to read this question. I want you to read this question and right after this इसके बाद सारे क्वेश्चन थोड़ा इजी है. ये वाला अच्छा सवाल है. It's a good question. Again, recursion based. So I've solved this already. Let's erase this so that you can read the question. Yeah. Please get across this. Please go across this. I'll be back in a minute or so. I'll be back in a minute. US, if you understood the question, please. US, if you understood the question. Okay. So basically, the question states, given a non-empty array nums containing only positive integers, find if the array can be partitioned into two subsets such that the sum of elements in both subsets is equal. Okay, so how do you solve this problem? Subsets meaning subsequences. The first thing that definitely comes to my mind is it states, can you divide them into two subsets? So first thing foremost, whatever is the sum of this, it has to be even. Is that clear? It has to be even. Otherwise, you'll not be able to do this. So first thing foremost is you will have to iterate across nums and you will have to do a sum plus equal to id. Now, you know one thing for sure, if sum and it's an odd number, you return a false for sure. If the sum is odd, it's definitely not possible. Do you agree with me or not? It has to be even. Now, if it is even, can I say the question boils down to find a subset with a sum equal to sum by 2. If there is a single subset with a sum by 2, and the remaining elements will be the part of the other subset. Agreed? The question actually boils down to find a subset with sum equal to sum by 2. So if you remember if you have seen any of my recursion videos, it's a very simple one. क्या use करते हैं? Like you'll just use a function with an index. Always dp is written on index. The second variable can be sum. Okay, so you can definitely call this function stating like if you just want a function, start with index 0 and please go on with sum by 2. Let's see if you can get someone with sum by 2. Now you always go on till you don't, like you can just carry the vector as well. Very standard, very standard problem. So I can be like, if index at any moment reaches sums dot size, I can return, if the sum is now equal to 0, you can return a true. Or else what are the ways? Pick someone. Do you agree that you can pick someone into your subset? Or you can say not pick someone into your subset. Agreed? So if you're picking someone into your subset, can I say what you're doing is you're moving to the next index, because for the current index you have decided you'll pick it, and you'll move to the next index stating sum minus sums or nums, whatever it is, nums, sum minus nums of index, because you're reducing the sum. And can I say over here it will be function, you will move to the next index, sum minus, there will be no, because you're not picking up, you're just moving across. Now this is a function, boolean pick function. This is a function of boolean non-pick. So if you have seen my recursion series, I've made sure that this is something pick and non-pick, you understand. So can I say pick or non-pick is what you are going to do? Do you agree? Do you agree that this is what you will have to do? And can I say, if I'm looking for a boolean, I can directly return this, assuming whatever it is returning. Now, if I just run this code, it's definitely going to run. True. But if I submit this, it will give TLE. Why? Because we have not yet memoized it. So if I carefully observe, can I memorize it? I think can we memorize it? That's a very big question. Let's understand. Can we memorize? Now, if I see index and if I see sum, there are two variables that needs to be memorized, because these two are changing. But can we memorize it? That's the question. Now, assuming every array element is 100 and there are 200 elements, can I say a 2 into 10 to the power 4 will be the maximum sum that you can have? Assuming every element to be 100 and if there are 200 elements, can I say the maximum sum will be 2 into 10 to the power 4? Agreed? The maximum sum will be 2 into 10 to the power 4. There is no doubt in that. And can I say the index will be 200, which is this. This apparently takes you to something like 4 into 10 to the power 6, which is quite high, like which is a bit high. It might give you TLE. That's the reason it gives TLE if you submit this. Like let's try submitting it. But I hope you've understood what I'm trying to say. So basically, if I try to give a vector now, if I try to take a vector of int dp, and I can be like, I definitely need n, where this n will be nothing but nums dot size, and I can be like the other one will be vector of int and sums by 2 plus 1 comma minus 1, as simple as that. So once I have done this, what I can do is I can definitely pass on the dp here. Very standard. You can just give a vector of int and of dp, and over here you can just pass on the dp. Over here you can just pass on the dp, and over here you can write dp of index sum equal to, and over here you can just write one more lines dp of index sum. If that's not equal to -1, you can definitely return dp of index sum, correct? And now if I try to run this, should be fine. मैं नाम से तो लिखा है, सम्स कहाँ लिखा है? ओवरफ्लो हो गया ऐसा, ओवरफ्लो क्यों हो गया? Okay, so one more thing that you can also write is, if at any moment sum goes lesser than 0, you can return a false. That's another case that you can write. If at any moment sum goes lesser than 0, you can definitely do it. And if you just try to submit it, you will see kill mostly. चल कैसे गया? ये अच्छा चल गया तो मुझे क्या था? Anyways, so this is how you can do it. Is this clear? Is this clear? Is this clear to everyone? Quite simple. Like we can do a space optimization on that. Again, I'll teach that on my DP series, not here. बाद में DP series में पढ़ा दूंगा space optimization. एक टेक्निक सिखाऊंगा, सारे में हो जाएगा. Basically, the index parameter is not required. Like even if you omit the index parameter, it's still gonna run. Like if I just show you, I'll just omit the index parameter. ठीक है, तभी चल जाएगा. If I omit that because index is not required over here. See, if I just remove this and if I just write int and just have the summation parameter, okay, then also this will run, because we don't want to know at an index what happened. We just want to know a sum is possible or not. So that's the core idea about this. Like if I just try to run this, it will still run. अब कहाँ फ्लो हो गया भाई? तू जान मार के रहेगा तू तो. So if you just try to submit this as well, it will still work, as you see. The reason is the DP is over here is not dependent on an index. You don't want to know at an index if a sum is possible or not. If you're forming sums, if you know a particular sum is possible or not, that is what you need. Okay. So if you can just translate this into a DP of a summation, and the space complexity will be big of n, and the time complexity will be still n into sum. Clear hai? Like the US from everyone, very standard problem. Let's take it to 500 likes. Come on guys, let's take it to 500. अभी तो भीड़ आएगी. कोडशेफ का कॉन्टेस्ट खत्म होगा तो बहुत भीड़ आने वाली. एनीवेज फटाफट लिख दो. Yes everyone. Less from everyone, right? Amazing. Superb. Quite standard, and yeah, you can optimize this further to convert this into a normal stuff. Okay. Easy question. UQ. कोडशेफ का भीड़ अभी यूट्यूब पे चली. यूट्यूब या टेलीग्राम पे. How many problems have you done? How many have you done till now? 1, 2, 3, 4, 5. 5 in 2 hours. Okay, read this question, please. Read this question. EQ if you've understood this. Give me EQ if you've understood this. Give me a EQ if you've understood this. आयुष सारा वीडियो मैं बना दूंगा तो बाकी दुनिया क्या बनाएगी? बाकी दुनिया से बोलो. Are you guys submitting with me? Are you guys submitting with me? A parallel. Pradesh is saying UQ, US, UC. How many of you can solve this problem, by the way? How easy, yeah? Find the longest consecutive character. The longest consecutive character. एक्सप्लेन करना भी मतलब पाप है. क्या ही एक्सप्लेन करूँ इसमें? डीपी पढ़ने वाले बंदों को अगर मैं ये एक्सप्लेन करूंगा तो फिर वो मुझे ही गाली देंगे. I'm not going to explain this. Simplest you can get. पोपट ना हो जाए. रॉन्ग आंसर आ गया. कितना बड़ा पोपट होगा पता है? चल गया. Anyways, done. नहीं, count 1. ठीक है, count is 0. Clear? Understood everyone? US. Please submit in parallel. Please submit in parallel. Please submit in parallel. Count equal to 0 से start करेगा अपन. Because I have mentioned previous equal to s of 0. Yes to everyone. Very simple. Just kept a counter of previous and kept on counting. Increased counter and updated counter with maximum. Got it? भैया इस क्वेश्चन में मत पूछो. अंडरस्टूड. सॉरी, गलती हो गया. नेक्स्ट वन. अगेन अ वेरी इजी क्वेश्चन. अच्छा लग रहा है इजी क्वेश्चंस करके अब तो. प्लीज चेक दिस क्वेश्चन. मैं कभी सीएफ प्रॉब्लम सीएफ से नाता रिश्ते तोड़ चुका हूं. इतना मेहनत कौन करेगा यार? सीएफ कॉलेज के बंदे जो लोग यूट्यूब करते हैं उनको पकड़ो. प्रियांश को पकड़ो. क्वेश्चन यूक्यू. इंटरव्यू में ग्लोबल वेरिएबल्स अलाउ नहीं करते, बट इफ यू यूज क्लास इन क्लास, इफ यू यूज ऐसे प्राइवेट करके लिखोगे तो दैट्स अलाउड. दिस इज मोस्टली डेटा मेंबर्स. So this is not a global variable. Like if I declare this n is not a global variable. It's a data member to the class only. Not a globally declared. But generally what you people do in interviews is this. You write like this and over here you write int n. So this becomes a global variable. Don't do this in an interview. In an interview, always write a class, public, and the function that you want to write. Always. UQ everyone. Come on guys. UQ. Super cool. UQ. Fatahat. Given the root node of a binary search tree and two integers low and high, return the sum of values of all nodes with value in the inclusive range low and high. So in this, if the range is given low 7 to 15, this is in range. This is this is not in range. This is in range. This is in range. Yeah, these three in our range. So if you add them, you get 32. So you're given a range, you have to just add it up. You're given a range, you just have to add it up. Does that make sense to everyone? Does that make sense to everyone? मेरा स्ट्रीम जब मैं मन मौला आदमी हूँ भाई, जब मन करता है ले लेता हूँ. So can I say I'll do a post order and I'll visit every node and I'll add it? I'll just do a post order. I'll visit every node. I'll check if they lie in the range and I'll add it. Agreed? Agreed? मेरा ट्री सीरीज देखा है, ये तो बच्चा वाला लगेगा उसको, अगर किसी ने मेरा ट्री सीरीज देख चुका है. Agreed everyone? So can I write something like this? Return. Let's check this guy. Root minus val. Is this if it is, plus it up. If it'll give you 1 or else it'll give you 0. Plus it up with range sum BST root left low high range sum BST root right low high and just keep on adding whoever is there. Oh, एक सेकंड. क्वेश्चन कुछ और था क्या? एक सेकंड. नहीं, मैं कुछ अलग ट्राई कर रहा था. मतलब मैं एक लाइन में लिखने का कोशिश कर रहा था, चला क्यों नहीं मैं वो देख रहा हूँ. लिखने का तो मैं ऐसे लिख दूँ, बट मैं ऐसे ट्राई कर रहा था. I was trying something different. That is what I'm seeing why it did not run. अच्छा, नंबर ऑफ एलिमेंट्स नहीं काउंट करना है, सम काउंट करना है क्या? आई काउंटेड नंबर ऑफ एलिमेंट्स. थैंक यू. सो इफ दैट्स द केस, इसको मैं कैसे एक लाइन में लिखूं? लिख दिया एक लाइन पे. तो बेसिकली लाइक कंप्यूटर मल्टीप्लाई भी कर सकते थे. गुड आइडिया, मल्टीप्लाई भी कर सकते. नाइस आइडिया. डन. इजी. 2019 पे किया था. Everyone's comfortable. Easy enough. Like if it is, then add root val, otherwise add 0. Everyone's comfortable. Submitted, everyone? Did everyone submit? Done. Okay. Done with this. Let's go to the next question. I'll not do linked list. इधर जोड़ो उधर जोड़ो, बहुत माथा गच्ची. I'll not do linked list. You can do it yourself. It's a good question. This minimum height tree is a good question. This question I'm skipping. A shit question. Insertion short. Linked list पे माफ करो. You can do it yourself. Can time complexity meet better? How will you meet? Was it a binary search tree? Oh, I did not see. Was it a binary search tree, by the way? Was the previous question a binary search tree? I did not see. Oh, yeah. Yeah, you can make it better. Yeah, you can make it better. It was a BST. Can you make it better? Yeah, if it goes lesser than left, there's no need to do it. If it goes greater than high, no need to do it. Can we make it better? Yeah, left में नहीं जाएंगे. Yeah, TC can be made better since the BST. We can make the TC better. Basically, we will not traverse in the left. No, we will. Yeah, we will not traverse in the left if the guy is lesser than low, and we will not traverse in the right if the guy is greater than high. That's how you can do it. That's how you can do it. Yeah, correct. Sure. It's a BST, by the way, so we can still do better. Like, we will not traverse in the left if it is less than equal to low. We will not traverse in the right if it is greater than high. That's the change that we can do. Third space will reduce. Yeah, कर लेना कुछ easy है. ये वाला करते हैं. अच्छा क्वेश्चन ये वाला करते हैं. ठीक है. Dinner time. Bye bye. आज मैं पूरा सब लेके बैठा हूँ. आज मैं सब खाऊंगा. क्वेश्चन पढ़ लो. क्वेश्चन पढ़ के बताओ. क्वेश्चन समझ में आ जाएगा तो बताना. ठीक है. No, so that depends on the range. क्यों रेंज लेके घूमना पड़ेगा. ऐसा रेंज लेके घूमना थोड़ा सोचना पड़ेगा. दिमाग आई थिंक नहीं चलेगा. क्या रेंज का सर्च स्पेस घटेगा तो मैं सोच लूँ. हाँ, अगर रूट लो से छोटा हो गया तो रूट का लेफ्ट हैंड साइड का सब चीज लो से छोटा हो तो मैं क्यों जाऊंगा. एंड सिमिलरली अगर रूट बड़ा हो गया तो रूट का राइट हैंड साइड सब बड़ा हो तो मैं क्यों जाऊंगा. सही तो था. अरे कान साल को मेरे को नहीं पता. आई जस्ट स्टार्ट फ्रॉम द लीफ नोट. कान साल को क्या दिमाग. कान साल को simple start traversing from the leaf nodes. Start traversing from the leaf nodes. The moment you don't have any remaining guys, you can say that that's it. Let's read the question. मेरी प्लेलिस्ट नया हो तो मत देखो. पहले बेसिक कर लो फिर मेरी प्लेलिस्ट देखना. Not like that. Why do you need to take a subkind degree? That's my question. Why do you need to take subkind degree? Do you actually need subkind degree? I don't think that. क्वेश्चन समझता है. क्वेश्चन समझने की कोशिश करता है फिर करेंगे. ठीक है. So basically it states you'll be given a graph or a tree where the edges are given to you A to B. Like for an example, over here the edges are given 1 0, 1 2 and 1 3. So you can form all, like if you root the tree at the 0, it'll look something like. If you root the tree at 1, it'll look like this. If you root the tree at the second, it'll look like this. You root the tree at 3, it'll look like this. So basically, among all of these, if I ask you which is the minimum height, you will say the minimum height is 1, and there is only one guy which is rooted at 1. So you will have to tell me if you root the tree at which node you will get the minimum height. So I can say that if you root it at the node 1, you will get the minimum height 1. Okay, that's what the question is. For an example, if I just go down over here, if you take this, it can be rooted in various ways, but only via rooting at 3 and by rooting at 4, I can see that there can be a height of 2, and that's the minimal that you can get. Like if you root it at 2, the height will be 3. If you root it at 1, the height will be 3. If you root it at 0, the height will be 3. But if you root it at 3 and 4, the height will be minimum, and that's 2. So you have to return the nodes. Question is clear? Is the question clear? Let's hit 500 at first. Let's please hit 500 at first. Is the question clear? Is the question clear to everyone? What if we root at 5? Again, the height will be 3. Others, the height will still be 3. Okay, so you have to figure out at which node will you root it so that the height is minimal. That's what you have to figure it out. And so how can you figure it out? That's a very critical question over here. So one of the ways that I can say is, can I say like if I just draw a tree and if I just give my thought process to it, if I just root the tree, just do it. And if I try to give my thought process to it, can I say it'll be like logically, if a tree is something like this, if a tree is something like this, if I figure out the longest path, and in that longest path, like whichever is the middle node, like in this case, if I carefully say you, ये side में क्यों आ रहा है आज? चला जाएगा. If I figure out the longest path, this is it, and I ask you which is the middle node, can I say this is the middle node of that longest path? Now, if I can figure out this middle node of that longest path, can I say in simple that if I figure out the middle node of the longest path and if I try to root it according to that, it will give you the minimal height, which is definitely an height of 4, Do you agree with me on this? If you get the longest path in a binary tree, and if you get the middle node of that, you will tend to get this node will be the middle node. Do you agree? Yes or no? If you try to figure out the longest path, and in that longest path, the middle node, because there are 4 nodes here, there are 4 here. So the height will be 4, which is the minimal, and this node will be where you should root the tree at. आएगा नहीं समझ में? Correct. Now, will there only be one middle, or can there be multiple middles? Will there only be one middle? Like in this case, the 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 was the path's length, thereby there was one middle. But what if I just add one more node? Then can I say this time the path will be till here, and this time I can't assure you that this is the middle, because if I take this guy as the middle, we still have 5 nodes here and we still have 4 nodes here. And if I take this guy as the middle, we have 4 nodes here and 5 nodes here. So if I try to think it on a logically, I will always have in odd one node with minimal height. Very basic. One node with minimal height. And in even there will always be 2 nodes with minimal height. No matter what you do. In even there is bound to have 2 nodes with minimal height. I cannot have 3 nodes. It's practically impossible. I've given you the intuition behind this. Correct? So can I say this? That if it's an odd case, I will have 1 node with a minimal height. And if it's an even case, I'll have 2 nodes with a minimal height. That's super duper short to me. Everyone agrees with the intuition? Everyone agrees with the intuition, right? Everyone? Does that make sense? Okay. Now, the brute force will be to figure out the maximum path, and in that path try to figure out the bit. But again, that will take me a lot of time. So what I will try to do is, I'll be smart enough. and I'll try to remove the leaf nodes. Now, if I logically give you an idea, like for an example, just think of a necklace. Think of a necklace, okay? Think of a necklace like this. Think of a necklace like this. And in this necklace, can I say 1, 2, 3, 4, 5? So this guy is the middle. Yeah, this guy is the middle, 5 and 5. So if there is a path and I say I will delete one leaf together. 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 So at the end, you're bound to reach the middle. Do you agree? If you're removing right from the bottom of the tree and you keep on removing every node, the last node that will be remaining will be 0. Sorry, the middle. Do you agree with this or not? You have to agree. There's no other option. So in this way, I can think of, okay, Striver, let's do one thing. Let's start removing the leaf nodes one by one. And then again remove the leaf node. Then again remove the leaf node. Try to remove the leaf nodes as much as possible. I'm like, okay, makes sense. Let's try this on this particular tree. So what are the first leaf nodes? If I ask you, which are the first leaf nodes? You will like, okay, Striver, the first leaf node is, please remove them. Removed. So if I remove them, removed. Now I ask you, which is the next leaf node? Just this, not anyone else. Only these guys are the leaf nodes. Please remove. Next I ask you, which is the next leaf node? Next I ask you, which is the next leaf node? Left out with 2 guys. Why indeed your middles? Which I need your middles. Does that make sense to everyone? Does that make sense to everyone? Yes, can you tell me if it makes sense to you? In case it does, please let me know. We have 2 guys and those 2 guys are your middle. You have 2 guys and those 2 guys are your middle. So everyone's understood? Everyone? So I can say who are your middles? Now intuition comes about in degrees. I can say if I like, this is the last step, the last removal, the guys who are last removed. The guys who are last removed will be your answer. The guys who are last removed will be your answer. Got this? The guys who are last removed will be your answer. So these guys will be lastly removed because those are the last pair of leaf nodes. They will be your answer. The guys who will be removed at last will be your answer. So how do you figure out someone is a leaf node? Very simple. Their in degree has to be 0. Because if I draw a tree, these guys will have in degree. The number of edges into it to be 1. The number of edges into it to be 1. The moment I remove them, these guys now are having in degree 1 because they just have 1 edge into it. So can I say we just have to remove guys with in degree 0? This is how you determine if it's a leaf node or not. Agreed? Similar thought process. Do you have to check out the entire tree? No. If a leaf is removed, who will be the next leaf? Leaf के ऊपर वाले तो leaf बनेगा. राजा का बेटा राजा बनेगा. अभी बन रहा है. तो अगर मैं एक लीफ निकाल रहा हूं, जैसे रिमूव किया, उसके ऊपर का बंदा ही तो लीफ बनेगा. ये रूट थोड़ी बनेगा. तो एक बंदा निकल रहा है तो उसका ऊपर का चेक कर लेना, वो लीफ बन रहा है कि नहीं. हो गया. कर ले, कोड कर ले. पूरा इंट्यूशन दिमाग में बैठ गया. Is the entire intuition in your head right now? Is the yeah, you can remove the, that doesn't matter. Is the intuition, is the approach, everything clear so that I can now move across to coding this? It's a very simple code. It's a very simple code. Initially remove the guys with node in degree as 1. Remove them. After that, the guys who are left with in degree 1, again remove them. Again remove them. The last pair of nodes which are removed, that will be the answer. Go ahead. Okay. A lot of people are saying me to go ahead. सब यस क्यों नहीं बोल रहे यार? इतने आलसी क्यों? इतने आलसी क्यों? Why are you guys so आलसी? Then there is something which is given as the edges. So what I'll do is, at first I will try to create the graph. That's very important. Please try to create the graph. So I'll try to create the graph. That's my way of doing. Adjacency of n is given to you is n the number of nodes. Yes, n plus 1. That's zero based है क्या? Zero based है क्या? नहीं, zero based नहीं है. तो zero based है तो चल जाएगा. Let's traverse in the edges. Also, please keep an n degree 1 vector of int. Okay. So what I've done is, please, you can code with me, by the way. So I am going on the edges, and I can say there is an edge from it.first. So I can just create the graph or tree, whatever you're wishing to. So I've created the graph, and similarly I can be like it.second dot push back it.first. Okay. So this is what is done. Now I can say the in degree of it.first will be plus plus. I can say the in degree of it.second will be plus plus. This is how I can, because if I'm connecting an edge, yes, if I'm connecting an edge from someone to someone, both of their in degrees will be increased by 1 plus. Make sense? Now I know which are the leaf nodes. So let's travel across from 0 to n, because those are the node numbers. Let's figure out which are the leaf nodes. So I can say if the in degree of that node is equal to 1, I can say that it's a leaf node. Perfect. So let's keep it over here, q. So if it's a leaf node, I can be like q dot, let's keep the initial set of leaf nodes. So I have kept the initial set of leaf nodes. Does that make sense to everyone? I've kept out the initial leaf. I've kept out the initial set of leaf nodes, and just make sure if you're keeping the initial set of leaf nodes, please, because you're removing them. This is the first set of leaf nodes that you're removing, correct? So can I say, probably you can keep a vector as an answer. And you can be right, okay, these are the initial set of leaf nodes that I'm removing. So let me do one thing. Let me just, by the way, अच्छा एज 0 भी हो सकता है, कोई बात नहीं, अगर एजेस 0 भी होंगे तो कोई दिक्कत नहीं है. So I'm storing the initial set of leaf nodes. So store. Now what I'll do is I'll keep on removing. So this is how I've removed. Now if a leaf is removed, the next set will be उस लीफ से जो जो जुड़े हैं उनका अगर इन डिग्री 1 हुआ तो उनका भी हटा देंगे. समझ रहे हो? उनका भी हटा देंगे. So अभी करते हैं while q not empty. Let's get the node. So I can say the node is q dot front, and we can definitely do something like q dot pop. Okay. So this is what we have done. What's my job? My job is to say, okay, I've got some leaves. Now my job is to definitely remove these nodes. I'll be like, yeah, makes sense. You have to remove these nodes. That's for sure. So let's do one thing. You're removing some new nodes now. Yes, you're removing some new nodes. So what you will do is, these are a set of leaf nodes, right? These are a set of leaf nodes. So every time you come across, please remove it. So what you can say is, okay, let's remove all the guys. So you can say q dot size I plus plus. Everyone in the queue is a leaf node. Let's remove the nodes that are connected to them and are the new leaf nodes. Perfect. So what I'll do is, if there is someone, yes, if there is someone, so basically let's take the node as q dot front. Let's remove it as q dot pop. And now let's do one thing. ये बंदा एक लीफ नोड है जो हट रहा है, तो इस लीफ नोड को रख देते हैं. अब इनसे जुड़े हुए जो लीफ नोड थे वो कैसे निकलेगा? आउट ऑफ IT एडजेसेंट ऑफ node. So if remember this, if you are removing someone, you're removing this node. So can I say the in degree of IT will reduce by 1? That's for sure, because this node was connected to this IT. So the in degree of IT has to reduce. Do you agree that it will reduce? By the way, it will reduce over here as well. If you have removed this portion, यहाँ पे भी remove हो जाएगा. If after reducing this particular adjacent node is becoming a leaf, you can say क्यों भाई ये लीफ बन गया है, तू एक काम कर, तू इसको अपने पास रख ले. आया कि नहीं समझ में मैं क्या बोलना चाहता हूँ? क्यों भाई एक काम कर, तू इसको अपने पास रख ले. मैं बोलूंगा सही है, तो साइज बढ़ जाएगा क्यू का. तो एक काम करते हैं, यहाँ पे INT लेके इसको इनिशियलाइज मार देते हैं. ओके डन. नाउ once I have removed, I've got the new set of Q nodes. I think I'm good to go. Again the same process will execute. Again it will come back. Again it will remove. So for each set of leaves it will remove, and the corresponding leaves remove. They again come back, corresponding leaves remove. Keep on removing, and whatever is stored right at the end at the answer, whatever is stored at the end as the answer, what you will do is you will simply return that as your answer. And remember guys, one thing, just in case n is given as 1, what will happen? If n is given as 1, the edges will be 0. That means we are just given the root of the tree. So what will happen in that case, we have to understand. In that case एक बार चला के देख लेते हैं, 1 दे के भी देख लेते हैं क्या आता है. पहले इसको रुको, वेक्टर दिया होगा क्या? मेरी माय बैड. ऐसे कोड समझ में आ गया? एज द कोड क्लियर टू एवरीवन? एज द कोड क्लियर टू एवरीवन गाइस? Is the code clear to everyone? Very simple that. Okay, so let me just give one thing. Let me just check this out. इस पे one जाएगा आंसर. तो 1 जा रहा आंसर तो मैं खुश हूँ. हाँ, एक्सपेक्टेड 0 क्यों जाएगा? एक्सपेक्टेड 0. अच्छा 1 है तो 0 जाना चाहिए. तो 0 इधर से आया होगा, आंसर हटा दिया होगा. क्यू का साइज 1 है, गया तो होगा. डिग्री 1 तो आएगा नहीं ना, क्योंकि लीफ तो है नहीं, तो इन डिग्री आएगा ही नहीं. Okay, so initially we can keep definitely as pushback, just in case the cases for this as the root. No, I don't plan. Hula. That's how we can do it. I did it back in 23/9 September during my Google preparation. Nice. So is this clear to everyone? Is this clear to everyone? This solution is intuitive, man. I explained the intuition. As did I not explain the intuition? Why medium? How to reach medium? And why in degrees? Did I not explain you this? Did I not? I'm pushing now. Here I'm pushing. Here I'm pushing the new set of leaf nodes. I did not just cram the algo. I could have said topo sort kal ho jayega. I told you why am I thinking of a topo sort kind of algorithm. Okay, is this can I get a yes from everyone? Can I get a yes from everyone who's watching out? We just have 543. Come on, and I had a dream of having 2000 likes in the stream. Yeah, previously submitted. Again, as I said, in भावनाओं में मत जाओ. ये देखो, ये कब समझोगे तुम, कब समझोगे? चलो फिर करता हूँ, कब समझोगे तुम बताओ? व्हेन विल यू लर्न? भावनाओं में बह जाते हो। 229 देख रहे हो? 6 सेकंड्स में क्या ही होगा, वही किया होगा यार, थोड़ा बहुत ऊपर नीचे कुछ हुआ होगा। ये देखो वही है, देख लो। डीएफएस से किया है, इंटीजर 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 इंटीजर, ब्रूट फोर्स किया है, जो मैंने पहले बताया था। डीएफएस से 2 हाइट निकालो, दोनों हाइट का मिडिल निकालो, दैट इज व्हाट आई हैव डन, दैट इज व्हाट आई हैव डन। द नॉर्मल वन, figured out the height of the tree, the max height of the tree, and then figured out which is the minimal. Figured out the max height of the tree and then figured out which is the initial step that I said to you. Figured out the longest path, then get the middle, and if the length is an odd one, then 2 middles. That's what you have to do. Okay? 2 middles mx2 mx1 से आ जाएगा। कॉम्प्लिकेटेड है, रहने दो। अगर सीपी आता तो कर लोगे, अगर सीपी आता तो कर लोगे। बेसिकली गेट द लॉन्गेस्ट पाथ, आफ्टर दैट जस्ट डू दिस and you will be getting a very good solution. Cool. 24.4, we had plus 200 subscribers. Nice. Okay. Cool. Okay, so ये हो गया maximal square. It's a dB. Can you please read this question? It's a good question. Can you please read this question? Time complexity of this particular solution that we did will be it's very tough to compute because we're removing the leaf nodes. So leaf plus, again you're traversing the leaf plus leaf plus leaf. It should be big of n plus e, big of n plus v, n plus the number of edges, n plus number of edges. Vast हुआ, शुक्रिया. It's n plus v because what are you doing? You're basically removing the leaf nodes. So the total number of leaf plus leaf plus leaf will be the total number of nodes in the tree. The total number of nodes plus you're running a loop for this, so which will be big of n. Got this? So big of edges. So big of edges plus the number of nodes is the complexity. Clear है सबको? Okay, cool. Let's read this question, and after this, we'll. It's an easy one. It's an easy one, guys. It's an easy one. Simple DP है. इसका रिकर्सिव डीपी पता नहीं आएगा कि नहीं, मतलब नॉर्मल तो इसका इटरेटिव डीपी बहुत ईजी है. Please read the question and then I'll get started with this. I'll give you a couple of minutes to read the question. कितने लोग टायर्ड हो गए? 153 watching. We started with 200 plus. We started with 200 plus. We have just 50 DPN grids. Yeah, easy one. रिकर्सिव क्यों समझना है इसका? रिकर्सिव इंट्यूटिव नहीं है, इसका इटरेटिव इंट्यूटिव है, तो वो बता दूंगा. Brute force is if you have done largest rectangle in histogram, the brute force. For every row, prefix sum करके brute force हो जाएगा. मैं डीपी वाला ही बताऊंगा. कर लो बता दो. इसमें recursive is not intuitive. You will understand when I I'll tell you the solution. Recursive is not intuitive. Over here, iterative solution is intuitive. Maximum rectangle, maximum square can also be done with histogram. Basically एक केस लगा देना जहाँ पे लेंथ इक्वल टू ब्रेथ होता है हिस्टोग्राम पे, तो हो जाएगा ना क्रिम्नोस्कैट 3. Why DSU? I don't think there is a requirement of DSU. Why DSU? There's no requirement of DSU. शुरू करें? ये क्वेश्चन पढ़ लेते हैं. Given a m cross n binary matrix filled with zeros and ones. So there's a matrix given which is completely filled with zeros and ones, and you have to tell me which is the largest square which has all ones. Like over here, the largest square which has all ones is this green one or the red one. So what's the area of that square? 2 into 2. That's 4. So how do you basically solve this? So like let's take this example itself. फटाफट इसको लिख देता हूं मैं 1 0 1 0 1 0 0 1 0 1 1 1 1 1 1 1 1 1 0 1 0. So let me write this. Okay, cool. So this is what I've done it. Now can I say one thing for sure? If I am trying to write a DP solution for this, can I say this if I talk about this entire row, if I talk about this entire column, what am I looking for? What I am looking for is a square. Now when I say square, it means the length has to be equal to breadth. Okay, so assuming I am saying every dp of ij tells you what is the maximum square that ends at. dp of ij tells you the max square that ends at ij. What does that mean? That means if a square is like this, then this is where it ends. This is where it ends. That is what dp of ij will tell you. So can I say if I'm trying to write this particular matrix, so can I say if I am talking about what is the square that ends at here, can I say 1 will be the square, the length of the square that ends over here will be 1. If I'm talking about here, which means what is the length of the square among this, the maximum, I can be like, hey listen, there is no square that can end over here because there's a 0, so there'll be a 0. If I'm talking about any square that ends over here, so there is only 1 and there's 0, so there will be a rectangle if you take this, thereby only a single length square can end over here, right? Like if I'm talking about any of these are rectangles, so I can just form whatever is over here, either 1 either 0, because in this column, in this row rather, I cannot have, like if I'm taking this, I cannot have any square ending at here which doesn't starts here. Make sense? So can I fill it like 1 0 1 0 0? Similarly, can I fill this row, this column rather, which is 1 1 1 1? Do you agree or do you not agree? Anyways, गलत हो गया, 4 1s होंगे, तो ये लास्ट वाला रो नहीं रहेगा. कोई नहीं, लास्ट वाला रो हटा देते हैं. आया समझ में? ये आया समझ में? क्यों मैंने यहाँ पे 1 पुट किया? क्योंकि अगर मैं यहाँ का लूँ तो मैक्स जो एंड होगा यही स्क्वायर होगा. ये तो रेक्टेंगल है. सिमिलरली अगर मैं यहाँ का भी लूँ, मैक्स यही होगा, क्योंकि बाकी लेंगे तो रेक्टेंगल बन जाएगा. सिमिलरली अगर यहाँ का लूँ तो सिर्फ इतना ले पाएंगे, ये थोड़ी ले पाएंगे. So did you understand the filling up of the first row and the first column? Has everyone understood the filling up of first row and the first column? Has everyone understood the filling up of the first row and the first column? Everyone? Nice, thanks. Everyone has. Amazing, amazing. Everyone has understood this. Perfect. So can I say one thing for sure? Now, if I'm looking for something here, if I'm looking for a square ending here, can I say if there is a square ending here, if there is a square ending here, and if there is a square ending here, they can extend to this. Like logically, they can extend to this. But since over here there's a 0, can we have a square which ends over here? Can we have a square which ends over here, which includes these guys? Which includes these guys? Can we have? The answer is no. Why? Because we have a 0. In order to a square to end here and include this, every one of them has to be having a 1, which is not the case. Correct? So I can say over here there will be a 0 because there's a 0 here. Right? Similarly, if I take this case into consideration, if I'm looking a square that ends at here and includes these guys, it's a 0. So this guy cannot extend. This guy cannot extend. Even if this guy extends, it will form a rectangle. So none of them can extend because you do not form a square. So this guy will be individual because there's a 1. So there'll be a 1 length square. Make sense? Similarly, if I go over here, there is a 1, there's a 1 length square. There's a 1 length square, there's a 1 length square. But this is not a 1 length square. Thereby, if it was a 1 length square, then this would have expanded to form a 2 length square. But you cannot. Why? Because over here there's a 0 length square. Thereby, you can only have this and this and this. You will not be able to form a square. Thereby, this single guy will only be there, which is 1. So single length square. Perfect. Over here, again the same reason, single length square. Over here, again the same reason, single length square. Over here, again the same reason, single length square. But now here, let's understand. Over here, we have a 1 length square. Over here, we have a 1 length square. Over here, we have a 1 length square. And over here, there's a 1. So can I say that this will be a 2 length square? Because 1 is here, 1 is here, 1 is here. So thereby this becomes 2. Can I say this? Do you agree with me or not? Do you agree with me or not? There will be a 2 length square. Perfect. Perfect. Now let's understand going forward. Here's a 2 length square. So which basically means it's a square like this. There's a 2 length square. Here's a 2 length square. Here's a 1 length square. Here's a 1 length square. Here's a 2 length square. So if you are attaching a 2 length, a 1 length, a 1 length, how many will you take? The minimum of all these 3? The minimum of all these 3? 1, 2, and a 1. The minimum of all of these 3? That's 1. So 1 plus again 1, 2. Correct? So you're getting a 2 length square which ends at here, which is again obvious. You're again getting a 2 length square which ends at here, which is again obvious. Understood? Similarly, can I say 0, 0, 1 and a 0? So can I say the recurrence indeed boils down to be very intuitive and saying कि तीनों corners से लेंगे. So can I write it as the minimum of the upper corner, comma the left corner, comma the upper, like the right one. This is the diag corner, this is the left one, and this is the upper one. The minimum of these plus 1, and this plus 1 is only possible if array of I of j is equal to 1. Then only they will combine. Do you agree with me or not? Do you agree with me or not? Do you agree with me or not? इस पर agree करते हो कि नहीं? Yes or no? Everyone agrees? Because if there are 3 squares here, if there are 1 square here, there's 2 squares here, then you can only form 1 from all of these 3 guys. Got this? रेक्टेंगल होता तो क्या करते, मैक्स ले लेते। रेक्टेंगल होता तो मैक्स, मैक्स तो नहीं ले, मैक्स ले सकते थे क्या, नहीं मैक्स नहीं ले सकते थे, मिनिमम, हाँ मैक्स ले सकते थे रेक्टेंगल होता तो। समझ में आ गया? तो अगर मैं इसको कोड करूं तो कैन आई से ओवर हियर मैं 2 स्टोर कर रहा हूं, तो जब भी 2 आएगा मुझे पता है कि 2 लेंथ का स्क्वायर है, तो एरिया कितना होगा, डीपी ऑफ आई जे स्क्वायर is the area. The maximum of dp of ij is the area, correct? So understood. Then let's move to the code. Moving to the code, guys. So I know one thing for sure. N is equal to a matrix. Okay, so there is n matrix dot size. Number of columns will be so now what I can do is I can fill up the first row, which is this, saying dp of I, or at the first column, as matrix of ij, sorry, I 0 minus 0. Okay, perfect. It's done. Perfect. Similarly, I can fill up the column wise, j lesser than m and j plus plus. I can say dp of 0 j, now the matrix of I, sorry, 0 j minus 0. Perfect. So this is how I filled it up, and once I filled it up, it's a very simple task. You start from the first row, go on, you start from the first column as usual because all the other columns have been filled up. So now what you can do is dp of, like, if dp of I, sorry, if matrix of I j is equal to 1, then only you do it. Then dp of I j will be minimum of dp of I minus 1 j minus 1, that's the upper corner, I minus 1 j, that's the lower left one. तीनों का मिनिमम लेना है तो ऐसे तीनों का लिख देते हैं, dp of I comma j minus 1, and yeah, whatever it is, you just need to do a plus 1, or else you can easily put in okay. So once you have done this, you can say the maximum area will be max of maxi comma whatever dp of ij into dp of ij. That's it, and you can just go across and you can return the maximum. So over here, what I can say is maximum is equal to 0. That's the minimum area, and yeah, if you just run this code, I think this should be fine. Yeah, cool. So has everyone understood this? 2019. Nice. हो गया इसको. 0110. Right there. Maximum will be no, maxi should not be 1. If that will be wrong. You have to take from that. अब क्यों नहीं चला ये? चलना चाहिए, अब तो चल जाना चाहिए. Maxi equal to DP of I0 सही तो है. हाँ तो सही तो है. ये भी क्या ही जाएगा, 1-0 जाएगा. Maxi should not be 0. No, that's not. अरे यार, I'm shit. क्या हो गया मेरे दिमाग को? थक गया मैं, लग रहा है बहुत. Looks like I'm getting tired. 4 घंटा होगा कि नहीं देखते हैं. हाँ, सिंगल एलिमेंट भी तो स्क्वायर है, चल जाएगा. Cool, that's how it runs. Super good. Cool. So has everyone understood this? We can still space optimize this because we're just using I-1, J-1. We can space optimize this. Is this clear? Is this clear to everyone? रेक्टेंगल वाला वेरिएशन क्या होगा? मैक्स ही होगा. मैक्स लिख दोगे तो हो जाना चाहिए ना. इधर से आया, उधर से आया, इधर से आया. हाँ तो मैक्स लिख देना से हो जाना चाहिए, क्योंकि ओके मैक्स लिखने से तभी होगा अगर वो ऊपर वाला 0 नहीं है तो. बस चेक करना है. नहीं, मैक्स लिखने से भी तो नहीं होगा. मिनी होगा यार. रेक्टेंगल का वेरिएशन क्या होगा? एक सेकंड रुको. रेक्टेंगल का वेरिएशन सोचना पड़ेगा, उतना इजी तो नहीं है. रुको, अगर रेक्टेंगल बोलता हूँ तो क्या सीन होगा? रेक्टेंगल में दिस इज मेकिंग श्योर दैट इट्स स्क्वायर बिकॉज आई एम टेकिंग 3 corners and I'm attaching it. A rectangle can be okay. A rectangle can be basically, if you're taking the corner guy, then the minimum of 3 + 1 ये हो सकता है. ऐसे है तो ऐसे बढ़ जाएगा. तो तीनों को केस कंसिडर कर सकते हैं अगर रेक्टेंगल कंसिडर कर रहे हैं तो. रेक्टेंगल कंसिडर करो तो तीनों को केस कंसिडर कर सकते हैं, गेस. हाँ, 3 को केस कंसिडर कर लेंगे, क्योंकि अगर इधर कोई एंड हो रहा है, अगर यहाँ पे एंड हो रहा है, यहाँ पे एक बंदा एंड हो रहा है, उसका कोई वैल्यू है, तो मैं क्या बोल रहा हूँ? मैं बोल रहा हूँ कि भाई तेरा ये वैल्यू है, अब तू नीचे जा, तो नीचे वाला बंदा भी फिलअप होना चाहिए एटलीस्ट उतने बंदे से. हाँ सही है. नीचे वाला बंदा फिलअप होगा उतने बंदे से, तो फिर ये भी बन जाएगा. अरे रेक्टेंगल पे भी वैसे ही कर सकते हैं, सेम लॉजिक से. मिनिमम के जगह थोड़ा सा 2-3 और लाइन्स आ जाएगा. 2-3 लाइन्स और आ जाएगा. डीपी से होगा कि नहीं मेरे को सोचना पड़ेगा एक बार. हो तो जाना चाहिए. ऐसा क्वेश्चन तो होगा ही, मैक्सिमम रेक्टेंगल है क्या? थिंकिंग करेक्ट. हिस्टोग्राम वाला तो मेरे को पता है कैसे होता है. विदाउट हिस्टोग्राम इज देयर अ डीपी सोल्यूशन? आई एम नॉट श्योर देयर इज अ डीपी. हिस्टोग्राम तो इजी है. प्रीफिक्स सम ले लो, प्रीफिक्स सम लेके हर रो का मार दो. लाइक द हिस्टोग्राम सोल्यूशन इज वेरी इजी. टेक अ प्रीफिक्स सम एंड हिट इट अक्रॉस. But I'm not sure if there's a DP solution to it. Is there a DP solution? There is a DP solution. What did I expect? हाँ सही था, वैसे ही है. ऊपर का लिया है, नीचे का लिया है, प्लस कर दिया. तीनों का केस का अलग अलग कंसिडर किया. As I said, you have to consider all the 3 cases differently. That is what they have done. क्योंकि इसको कंप्लीट करने के लिए इधर से होना चाहिए, इसको कंप्लीट करने के लिए इधर से होना चाहिए, और इसको कंप्लीट करने के लिए दोनों साइड से होना चाहिए. तो सारे केसेस सबको लेने पड़ेंगे. दैट्स व्हाट हैव दैट डन. बट आई विल गेस रेक्टेंगल का अगर क्वेश्चन आता है तो द बेटर वे इज टू डू द हिस्टोग्राम वन. बेसिकली तो रेक्टेंगल क्वेश्चन आता है, हिस्टोग्राम का सोल्यूशन है कि नहीं पता नहीं. हिस्टोग्राम का सोल्यूशन कर लेना. जैसे क्वेश्चन होना है लार्जेस्ट एरिया इन हिस्टोग्राम. सो बेसिकली इस रो पे खड़े होगा, ये एक बनेगा हिस्टोग्राम, ये 0 बना, ये 1 बना, तो इसका मैक्सिमम निकालने का. फिर यहाँ पे खड़े होने का, तो ये 1 बना, ये 1 बना, ये 1 बना, ये 1 बना, लार्जेस्ट एरिया निकालो. फिर यहाँ पे खड़े होने का, ये 1, ये 1, ये 1, तो ऐसे करके सारे रोज पे रेक्टेंगल हिस्टोग्राम लगा देने का. बिग ऑफ n में होता है हिस्टोग्राम, तो रोज n है तो n × n n² में हो जाएगा हिस्टोग्राम. यू कैन डू इट. -0 समझ में नहीं आ रहा तो सोल्यूशन नहीं समझ आएगा. हिस्टोग्राम तो यू कैन डू इट ना, लार्जेस्ट रेक्टेंगल का. इट्स वेरी इजी. n² हिस्टोग्राम वाला भी. You could have also done this one using histogram, if you would have applied histogram पे L equal to B वाला concept. You can watch my histogram video. There's a video on take it forward. Watch this. It's a wonderful largest area in histogram. I'm not sure if this, yeah. देख रहे हो भाई का वीडियो पहले आता है. तो लार्जेस्ट एरिया इन हिस्टोग्राम देख लोगे. इसका बहुत तगड़ा है. ये पार्ट 2 है क्या? इसका पार्ट, ये 2 पार्ट्स में, तो इसको पहले देख लेना. इसके बाद यहाँ पे पार्ट 2 है. यहाँ पे पार्ट 2 है, पार्ट 2 देख लेना. तो पार्ट 2 पे मैंने अच्छे से बताया. ये देखो, ये मैं बहुत बेकार लग रहा हूँ. यहाँ पे मैंने अच्छे से बताया पूरा हिस्टोग्राम, एक एक करके धीरे से इंट्यूशन बताया गया है. तो ये वाला देख लोगे तो तगड़ा मजा आ जाएगा. ठीक है. सो जस्ट मेक श्योर यू वॉच आउट पार्ट 2. देयर इज अ पार्ट 2 टू इट. पार्ट 2 इधर ही आ रहा है. ये क्या बात है? व्हाट द फक. रुको, मैं इसका पार्ट 2 सही करता हूँ. Just give me a moment. I'll fix this part 2. से कैसे भाई? तो गलत चीज़ है ना, मतलब अच्छा वाला सोल्यूशन दिख ही नहीं रहा. लार्जेस्ट, लोग तो वही करके चले जाएंगे ना. लार्जेस्ट रेक्टेंगल इन हिस्टोग्राम. पार्ट 2 करो, पार्ट 2 करो राज. पार्ट 2 है. इसको लाया पार्ट 2 में, इसके एडिटिंग में गया, पार्ट 2 पे ये लगा रहे, लगाया. इसको लिखा पार्ट 1, रीड कोड 84, सेव कर दिया. So now if I just try to check it out, here it goes. Yes, अब सही है. अब इसका पार्ट 1 है ये, और पार्ट 2 ये रहा. पार्ट 2 भी है. ठीक है, इसको देखना, पार्ट 2 को देखना, बहुत समझ में आएगा. ठीक है, आ गया समझ? तो प्लीज मेक श्योर इसको पार्ट 2 देख लेना. अच्छा, लेफ्यू कैश में भी सेम है क्या? पार्ट 1 पार्ट 2? अरे मैंने इसी में तो गड़बड़ किया है. मैं तो सही सही किया था. कोई नहीं, सह लेंगे. ओके, नेक्स्ट क्वेश्चन फॉर द डे. This I will do afterwards. It's a DigiDB problem. I'll do afterwards. Good problem. I'll add this to my DB series. Decode string minimum. थोड़ा सा easy questions पहले कर लेते हैं, फिर ये सब करते हैं. Decode string करना है अपने को. चलो decode कर लेते हैं, easy है. Read the question. It's a stack based question by the way. It's a stack based question guys. Please read it. अच्छा, मैंने YouTube भी बंद कर दिया क्या? Comments कैसे पढ़ूंगा? CodeBeyond लाइव चल रहा है क्या? CodeBeyond का दिखा रहा है. Is it showing? CodeBeyond. Okay, now it is there. Explain on the board sir. हाँ, डांस करके ये करूँगा. It's 2:53. I think we have a lot of questions. Do we have a lot of? Yeah, we have a lot of questions left. I think कितने questions किए अपने आज? 1 2 3 4 5 6 7 नहीं 8 9 questions कर लिए. 9 questions in 3 hours. 3 per hour. Good. It's a stack based question because generally these kind of questions are stack based. I think we'll, should we end the stream? Or should we continue? Because I think are you guys tired? मैं तो tired हो गया. Are you guys tired? It's tough to stream for 3 hours continuous. मेरा गला सूख रहा है. Are you guys tired by the way? End कर देते हैं. बचा कुछ प्रॉब्लम बाद में कभी कर लेंगे. What do you say? People saying continue. उनको मेहनत लगता है. Let's do one thing. Let's keep the remaining questions for जनवरी 2 को. तो मैं बिजी हूँ, कल भी नहीं हूँ मैं, और कर लेता, कल मैं हूँ नहीं. एक डेट देखने दो मेरे को, रुको. बहुत मुश्किल है यार, काम बढ़ रहा है, जनवरी से काम बहुत बढ़ जाएगा. ओह, I think I'll end this because otherwise this will go off. Otherwise this will go off. So I'll end this because I think it's done. 4 hours streaming is very, very, very tough. Especially in my streams, it's very tough because I get a lot of audience. तो मुझे बहुत बोलना पड़ता है कंपेयर टू अदर पीपल स्ट्रीम जहाँ 10-15 वॉचिंग होता है. तो यू ज़्यादा बोलो मत, अपना बोलते जाओ. ठीक है. ये छोड़ दो यार, ये बाद में करेंगे. काफ़ी ये वाला पूरा ड्राई रन करके दिखाना पड़ेगा, आधा घंटा जाएगा. मुझे नहीं लगता मैं आधा घंटा और बोल पाऊंगा. So let's end this as of now. We have had a wonderful stream. I hope you enjoyed it. Enjoy किया कि नहीं? 9 सवाल फटाक से हो गए. अच्छे सवाल थे, इसलिए थोड़ा टायर्डनेस है, बट अच्छे सवाल थे. इसके बाद तो इजी सवाल है. मतलब ये वाला इजी है, ये भी इजी है, ये भी इजी है, ये भी इजी है. ये तो मैंने करा चुका हूँ, ये मैं टोपो शॉट में करा चुका हूँ, तो देख लेना. ये भी मेरे SD शीट में है. ये तो बच्चा वाला है. ये भी इजी है, ये भी इजी है. ये भी SD शीट है. ये भी है इस पे ट्री सीरीज पे. ये भी इजी है. अरे इजी है यार. इसके बाद तो 30 मिनट और नहीं. अब मैं जाऊंगा तो मैं जाकर सो जाऊंगा भाई, पागल है क्या. आज अब हो गया आज का स्ट्रीम यार. आज जाऊंगा तो सोऊंगा मैं. Okay guys, so I'll just end this up. It's been a wonderful 3 hours. Thank you for joining in, and yeah, thank you for joining in. That's what I'll say. Thank you guys, and have a good New Year. Stay home. Mostly everywhere there is a lockdown, so try to stay indoors if possible. Like मैं तो गाँव जा रहा हूँ, but for you people, try to stay indoors. Don't go to outside pubs वगैरह. And yeah, have a New Year resolution कुछ रखो अच्छा खासा. And hopefully your new year is filled up with a lot of betterments, skill wise, health wise, family wise. Wish you a lot of happiness, and all the best guys. मिलेंगे न्यू ईयर में नेक्स्ट. ये साल और मैं नहीं आने वाला, तो रखता हूँ. बाय बाय, टेक केयर, गुड नाइट.